This conference will now be recorded.
Yeah, thank you. Thank you very much, guys. And welcome all. So today we are going to discuss. I I hope that my voice is coming clearly to all of you guys. There is no resound or nothing. Yeah, thank you. Thank you, Ijam. All right. So network policy. This is the one of the topic that we are going to discuss. Another topic that we are going to discuss today is the security, and third one which we are going to discuss is something called as config maps. These are the three important topics that we will be covering today. So consider that we have a network policy. Network policy. What is the meaning of network policy? Why do we need it? So in last session we have started that, but let me just put up in front of you. So you let's say that you have this network spaces. This is my one network space. This is my another network space, or there might be a multiple network spaces in the cluster. So I can give the name to this as, let's say, K21 is the namespace, or this, let's say, make it as a prod, and this one is my dev. These are the two namespaces. And one thing is that if you have launched multiple containers inside this container, this is my container one, this is my, or pod one, you can say this is my another pod. And in another namespace also you have a couple of pods there. So this is your pod one, pod two, this is pod 3, let's say, and this is pod 4. All right, so these are the pods, and having that they are from the different application, maybe from the same application. But guys, one thing is sure, that all these pods will be able to talk to each other even though they are in the different namespace, right? So that is a major problem. They are not isolated, they may be visibly isolated. They are, if the user is trying to log into this particular namespace, the pods from other namespace will not be available to the this user, right? So this is the problem. But if you have access to these pods, if you log into this pod, then you can easily log into any other pod as well. You can ping to this pod, or from this pod to this pod you can easily ping, guys. So there is no isolation between the pods, even though there is isolation with the help of namespace. So how do we do that? What should we do to isolate them? How we can protect them so that the security will not be compromised? So guys, for that purpose, this network policy has come into picture. Right. So now what we should do here, network policies. So how we are going to deploy these, and what are the different methods that we are going to see. So basically, these pods are isolated by using the namespace labeling, right? First of all, you can use the labeling concept to isolate the pods. So consider that you have these pods, or a couple of more pods are also there, and let's say that this is a pod which has been labeled as, it may be in different namespace, or first of all we'll discuss about the same namespace. So let's say that we have one more pod here, pod 1, pod 2, and pod 3, right? And they are labeled like this. Let's say that I will label this as uh, development is equal to prod. I will label this as a development is equal to prod 1, and I will label this as prod 2. Okay, all right, friends. So now we will see that how we can protect this. If you log into the pod 1, you can easily ping the pod 3, or if you want to log into the pod 2, you can easily access the pod 3. Right now there is no isolation between the pods in the namespaces or namespace. So what we want to do here now, there are three important terminals, a couple of important terminology are there that we need to understand. The first important terminology is there. If this is your web server, let's say this is your web server. Let me put it here like this pod contains the web server. This pod contains the application. Okay, and another one is you have third one is a database, and you want to have some connectivity between them. So how do you do that, right? So you should be able to access from web server to application server, from application server to database server. So this is your database server or database pod is there, right? So whenever the traffic is flowing out of, whenever the traffic is flowing out of the one pod and going to the another pod, then this traffic becomes the ingress traffic for this particular application server. So this is the ingress traffic, which is incoming traffic to the pod 3. When the traffic is leaving from the pod 3 to pod 2 like this becomes the egress traffic. So all the traffic which is coming towards the pod is called as the ingress. All the traffic which is going out of the pod is nothing but egress traffic. So this is important to understand. So this becomes when we are trying to access from the web 1 to web this app server, it becomes the egress traffic that becomes ingress for this application. So what we are going to do now here, we are going to set up the policies. We are going to create some couple of pods with some labels, and we will see that whether we can control them from the accessing other pods or not. And we'll use the ingress policy as well as ingress policy type to control the traffic or for the isolation purpose. If you have multiple policies assigned in one namespaces, right, or for the on the basis of the labels, then the union of the policies is calculated. So the common policies get applied in case there are multiple policies applied to the pods, okay, with the help of different network policies. So now let us see that how we can deploy this one. So first thing is that pods are not isolated. To isolate them, you have to apply the network policy. If you want to apply the network policy, you have to control the ingress traffic as well as you can control the egress traffic, which is going out, right? And if you are applying a multiple namespaces within the namespace or in the different namespaces, okay, then basically if there are multiple network policies are there, then the unions of that policies are is applicable or its impact is there. Okay, so now let's move ahead and deploy this one. So I would like to create one simple pod for you, and then we'll deploy another pod, and then we'll create a network policy, and then we'll come back and we'll go for the exercise which is given in the activity guide. So let's do one small example, guys. So this is my master node. Then let me see if my all nodes are running. Yeah, they are all. kubectl get pods -oy. Do I have any? No, there are no pods. Let me deploy one pod, kubectl run pod 1. This is pod 1 I am deploying. We are creating by using an image called as Nginx. Okay, and I would like to label here as labels. So what is the label? Let's say, okay, environment is equal to production. Okay, so we have started one pod whose label is env is equal to prod. So kubectl get pods -o void. So this is running on the worker 2. Its IP address is this, and this is a pod 1. And if you want to see its labels, you can use the labels also. And its label is env is equal to prod. Okay, let me create one more pod quickly using the same command, but I will give the name to it as a pod 2. Okay, and I'm going to label them as a env is equal to prod only, right? So let's keep that way. So you can see here now kubectl get pods -o void -- show labels, and you should be able to see that both pods are now labeled same. Right now there is no network policy, so they will be able to access each other. I would like to create one more pod which has a different label altogether. So let's create that one more pod called as a pod 3, and whose label is environment is equal to development. So now if you see that we have a different pods here. So two pods are having the same labels and one pod is having a different label. Right? So now what we want to do, each pod now will be able to ping each other. There is no question because there is no isolation. If I log into any pod, let's see if I log into pod 1, then we'll be able to access this pod 2 as well as pod 3. And if you want to check that, you can check it quickly also. kubectl execute -it pod 1 and then bash. I'm inside this one. I need to install the ping utility. Okay, it can be done quickly, guys. ept install IP utils, if I'm not wrong, -ping -y. Yes, it is installing. So now guys, let me ping this machine. So what is the IP addresses? I am inside this pod 1. Let's see that whether we are able to ping to the pod 2 and pod 3. So its IP address is 03 and 04. Let's see that whether it is pinging or not. It should ping, right? And it is pinging because there is no issue, there is no isolation at all. So it is pinging properly. Now what we want to do, now we want to apply one network policy in a such a way that this pod 2 should be able to ping from pod 1. So whenever you try to ping from the pod 1, it should get pinged from the pod this one, but this pod 3 should not get pinged from the pod 1. So
Hey
what?
Ramesh, can you also try to log in? Just try not only ping, log in also. Try to log in to the pod 2 from pod 1. No network policy.
So I need to enable the SSH for that one. If I have the some protocol such as SSH or FTP or something is configured on the pod 3, then only we will be able to access. Right now there is no protocol, right? So I can curl it. If there is a website inside that, I can curl it. I can see that one. Okay, I'm getting the website out of it, right? But there is no protocol which is used by which we can connect them. If I install the SSH inside that one, then it will allow me to do that. However, we have to use the user ID and password also. Then we have to create the user ID and password on the pod 2 or pod 3 so we can access it. Now, right now we are able to ping to the all the pods, right? So now let's implement the policy. So I'm inside the pod 1. I will go to the another terminal so that we don't have to again and again log into the pod. So let me go here, Kubernetes folder.
It's capital K.
Yeah, thank you. Kubernetes, correct. And I have a lot of policies. So what I'm going to do here now, let's we have kubectl get pods -o wide -show labels, right guys? And what is our target? Our target is that from pod 1 we want to ping to the pod 2 because their labels are same. So we want to write a policy in a such a way that okay, we will do this way. We'll create one more pod. I think we need to create one more pod here. Kubectl run pod 4, right? And let me use the command image called as nginx, and labels is equal to env is equal to, let's say, test. So now we have, yes, correct. Now we'll see this. It is creating a container. It will get created quickly. Yes, it is created. Now let me clear the screen and we'll have this access. Okay, now we need to write a policy in a such a way that this test pod, which you see here, right, which is deployed on the worker 2, should only get access from pod 3. Pod 1 and pod 2 should not be able to access this pod 4 ping. It should not ping. So in short, pod 3 should not be able to pod 3 should be able to ping to the pod 4, but not pod 1 and pod 2. So what I want to do that the give the access to the pod 4 from the pods whose label is env is equal to div. That is what we want to do. So now what I will do, I will just open one file, network policy ping.yaml, and I'll just delete some of them. I will delete this egress will run for some time. And you can see this is the network policy, the kind we are going to use. API version is this one. This is a version 1. I'm giving the network policy one as the metadata. And there are two policy types which we can use. One is ingress and another is egress policy type. I can choose any one of them. Right now, I'm going to use only one, so I'm just removing it. Okay, and now what we want to do, pod selector match label, this is equal to whatever. That is what I have used. So let me change it because we have used different one here, env. And what you want to do, you want to use a selector match label called as a test. So that means the pod whose label is test should be able to get the access from, should be accessed by, that is ingress rule, from pod selector match labels, and then I will use here this is equal to, sorry, env is equal to I think dev, right? The moment I deploy this network policy, by default or from all other labels, the access to this particular pod will get denied. Okay, so only it will be accessed from this one in the same namespace. Let me save it. So this is very easy to understand. This is not tough to understand, right? So this is the ingress rule, that is incoming packet, on which this pod selector whose label is test, and from which pod it should get pinged. Wherever the label is env is equal to dev in that namespace, we'll be able to ping that or access it. Not only ping, we'll be able to access, because by default it should access you all the ports, right? So guys, it is very important that it works only on the labels. Labeling network policy gets deployed with the help of labels. So we can allow all the ports. You can use pod selector and namespace selector labels to, as well as IP blocks to control the ingress and egress traffic. So let me apply this kubectl apply -f, and this is my network policy ping.yaml. Okay, and now you can see here kubectl get pods get network policy. Yeah, this is the network policy, and let me describe this policy. Kubectl describe network policy called as NP1, and it shows that this is the NP1 policy. Okay, and what it says that pod selector env is equal to test has allowed the ingress traffic to port any port specifically from pod selector env is equal to dev, and it is not affecting egress traffic. So egress traffic is allowed, it is going out, right? But it is by default all traffic is going out, but here this specific pod whose label is env is equal to test, that means this particular pod will be able to access from pod 3, that is env is equal to dev, but it should not ping from the pod 1 or pod 2. So let's try out, guys. This is the IP address of the 3, and we'll try to ping it from the pod 3, and we'll try to ping it from the pod 1 as well. Let's see what happens. So I'm inside the pod. Let me exit once and log in again and try to ping to the pod whose IP address is 3, right? And now see here, it is blocked, it is not pinging. This is proving that the label whose label is env is equal to prod or any other label other than the env dev, right, this pod will not be accessible. So now that is getting working. That is, guys, even if I try for the pod 2, because pod 2 is also having the same label, even if I log in there with the pod 2, this will not work. So let me ping to this particular IP address 10.40.0.3. okay, let me do it, guys, quickly. Update and apt install IP utils dash ping. Yeah, and this now installing. So let me try out now, guys. Ping. What is the IP address of it? 10.4. And from this also it will not ping. Yes, and it is not pinging. Okay. Now we will try from the pod 3, because pod 3 has the label which we have allowed called as env is equal to tail. So let me log in with this pod. Let me exit from this one and access the pod 3. So I'm inside the pod 3, guys. Let me just clear the screen so that you can see it properly. Most probably this will have a ping command. No, it is also not there. Apt update.
Hello.
Yes. And now let me just apt install. I hope that you are able to hear me, guys, right? Just give me some time. Let me complete this particular topic. Then I will pick up your questions, guys. IP utils dash ping. Okay, cool. So now I'm able to ping to the now let's I'm inside the pod 3, and now I want to ping to the IP address of this one. This should ping because we have allowed ingress rule. So let me try out, guys, and it should ping, guys, and it's pinging. All right, so I just want to show you one thing. So this is working fine, guys. Now what I want to do, that I want to log into the pod 4 and I want to check whether pod 4 is able to ping to all, because that is egress traffic which is going out of the pod 4. So that I want to test it. So let's log in with the pod 4 quickly and then come back. Some another example, ping. So this is my pod 1. Apt update. Okay. And apt install IP utils dash ping, and it is pinging there. Yeah, it is installing now. Now let's try out ping 10 Look, egress traffic is working. It should ping to all the IP addresses because we have not blocked the egress traffic. Look at this. By default, egress traffic is allowed. It's working. It's working fine, guys, right? You can see the 4 also it is pinging. 10 dot, sorry, it is 10.32. Yeah, it is pinging. So cool. So ingress traffic has been blocked, but egress traffic has been not blocked here. Okay, so this is something about the how we can block them from the same namespace, guys, with the help of this one. So if you want to allow the pod from the prod whose label is prod, what should I do? I can use the same network policy configuration file, and I can add another rule there like this one. We can have a multiple rules, guys. Okay, so this is another rule I am going to put here, that is called as env is equal to prod. Okay, this normal thing will help you to access it, right? So this test environment will get access from the prod also. So let me just put it here. kubectl apply -f and network policy ping.yaml. It's configured, guys, and now let me try to ping from the pod 1 again and see whether we are able to ping to pod 4 or not. Pod 4 is our test 1, and pod 1 was earlier, it is his name, its name is label is env is equal to prod. Now let me ping this IP address from the pod 1, and it should ping right because we have allowed the ingress traffic from the pods whose label is env is equal to prod, and it's working. Okay, so now it is allowed from all the pods, from the env is equal to prod as well as env is equal to pod. So this is something related to the ingress traffic, right? So now if I want to define the egress, that also we can plan. Egress is nothing but to whom you want to send the packets, right? That way you can plan it. So how do we do that? So first of all, what I will do, I will delete the network policy. kubectl get network policy. Okay, so this is the network policy. Let me delete it. I just want to show you the egress control so that NP1, so nothing is now blocked. Everything has been, all the security network policy has been removed now. Now what I will do, I will just recreate the network policy. So let me use this network policy ping.yaml with the same name, but just I will use the network policy 1 command underscore egress. Let's say use egress YAML. So network policy, let me open this one. So guys, first of all, if you want to block something, you want to block the incoming traffic to the pod whose label is env is equal to test. So how do we do that? Let's say that I don't want any traffic or anyone should access this pod. How we can do that? We can just write here ingress and this is a blank array, right? Guys, let me just see whether it is correct. Okay, so this is deny all ingress traffic. So if you don't want to access it from anything, you can use this one, deny all ingress traffic to specific pod. Then we can use ingress is equal to this blank array type. So what will happen? This will not allow any traffic to the pod whose label is app is equal to web1. And so let me deploy this one so that you can understand. Nobody will be able to ping to this particular pod whose label is env is equal to test. Let's test it quickly. This will be quite fast now. kubectl apply -f So those who know about the IP tables, those who might have studied in the firewall, what is the inbound traffic and what is the outbound traffic. It is similar thing, guys, here also in network policy. Okay, so kubectl apply -f. So kubectl get network policy, and you can describe it also. Kubectl describe policy, and you will be able to see that what it says. NP1. Yes, what it says that allowing ingress traffic none of the pod selected pods are isolated for ingress connectivity. So now if I try to log in, okay, let me try to log in here. Okay, so now what I will do, I will log into the pod 1 and we'll see that whether we are able to ping this pod 4 or not. This is IP address is this one. So let's kubectl execute. So let me go inside the pod 1 and try to ping. It will not ping it because it is blocked. From anyone, if you try to ping, it will not work, guys, because here it's all the traffic has been blocked, right? So pod 3, and let me ping it this one. It has been completely blocked. Okay, so this ingress traffic has been properly closed. I hope that you understood this network policy, which I have used for blocking the ingress traffic, right? Let me show you that again. Right, look at this. So completely blocked. So if I want to use egress also, what I can do here, I can just use here egress. For which pod you would like to do, for the pod selector, this one. And if you don't want to get connected to any one of this, so you can write here egress. Okay, so let me add egress traffic now. Okay, and instead of this ingress, I will use egress. Okay, just give me 2 minutes. I will allow you to ask the questions. So now what we are doing, guys, we are blocking all the traffic which is going from this particular pod to everyone will be completely blocked. So let me try out. Okay, so first of all, I need to delete that policy so that otherwise it will create a problem. Okay, and now let me deploy it again. Okay, and now let's kubectl log into the pod 4, right? This is my pod 4. So let's log in, kubectl execute -it, and this is a bash. And if you try to ping to any other IP address, because egress is blocked, so it should not allow to ping to any outside traffic. And see here, it is not pinging, guys. It is not allowing to ping because egress is blocked. So if egress is blocked, nobody will be able to ping also, because there should be output should go. Because if you have opened in door, if you close the door from the outside or you do close the door from the outside, the result is same. Nobody will be able to ping to each other, right? So this is nothing but egress control. So I hope that you have understood the ingress and egress concept. We will see that how we can block the particular pods which are coming from the different namespaces. So before that, let me see the questions quickly, guys. I will take the questions from the chat box and then you can ask the question. It should be problem if there is isolation of namespaces. I think, is there any other question? No, right? So Ramesh Prajapati is asking, it should be problem if there is isolation of namespaces, namespace not able to get. Pods are not isolated even though if they are in this different namespace. Okay. I hope that you got an answer, Ramesh, how to block them, right?
Yeah,
You can also,
yeah, I got it. But only question is like, suppose ingress and ingress, what I feel is like for pod which is inbound, it might be some pod, it might be outbound also, right? Like for example, if a request is coming to pod 2 and we are sending outbound request from pod 2 to other pod, for that pod it will ingress, right?
Right. Ingress is incoming traffic, egress is just outgoing traffic. It can be anything.
Okay, so okay, fine. Yeah, good.
Yeah, this is what I was showing. From the pod 1, if the traffic is going to the pod 3, then it becomes ingress for the pod 3, but it becomes egress for pod 1. So now packet is leaving from the pod 3, so it becomes egress and it is ingress for pod 2. Okay.
Yeah, got it. Thank you.
So
by default,
Ramesh,
one second. Yeah, is it related to the same thing? So
yeah. So if
okay.
egress is blocked, okay, and ingress is allowed, what is going to happen?
On the same one?
Yeah.
No, it is similarly like that one. Let's say that if somebody says that allow ingress from this one, allow this traffic, but do not allow this traffic.
No, let's say from pod
packet
1.
Packet will reach to the pod 3, but there won't be any acknowledgement from the pod 3, so there won't be any communication.
No,
you want to be incoming traffic and no outgoing traffic.
Right. You are saying, yeah, you are saying that go to the inside the home, but from the inside you have locked the door. So from the outside there is no lock, but from the inside there is lock, and that means there is no communication.
So in pod 1, if egress is blocked, okay, but ingress is allowed, okay, that means that from pod 1 you can't ping any other pods, but then from any other pod, okay, you can ping pod 1, right?
If the egress of the pod 1 is blocked,
yes,
nobody will be able to ping that, even the ingress is allowed.
So no, I'm little confused here. So let's say you have pod 1 and pod 3, right? Okay, let's talk about only these two pods. Okay, here now I want the outgoing traffic to be blocked from pod 1, okay, to any pods. Then egress should be blocked, right?
Correct.
Right. But then if ingress is allowed, okay, what does that mean?
Even though ingress is allowed, traffic will reach to the pod 1, but there won't be any acknowledgement because egress is completely blocked.
So that means egress is getting more high priority compared to ingress.
Yeah, everywhere in this is the rule of the firewall or anywhere in this world, that you should by default you should always allow egress traffic, always.
Yeah.
Okay.
Otherwise, even if ingress is allowed, I mean, the pod will not be able to acknowledge whether it has received any request from pod 2 or pod 3 or not, right?
Right. So I always give the simple example to understand this concept in the LAN card fundamentals. So if this is my LAN card, in short, every pod has a LAN card, and if there are doors are there, and if you block, or if you say that no traffic will go outside this LAN card, that means outbound traffic is completely blocked. So even though you have opened all the ports for entire world, but you have blocked the outbound traffic, there won't be any communication. All traffic will reach to this LAN card, but it will not acknowledge, so there won't be any communication. RX is there, TX is not.
So that means we should always play with ingress. Okay. I mean, we barely use egress. Okay. If we want to really hard block, okay,
No,
from any
egress is
particular pod.
yes, egress is used when your traffic is going to the database, right? You can write a rule, two rules, one rule for the ingress from this one, from the application server, and egress to the application server. That's it. So this DB
Okay.
will not send the packet to anyone else or will not receive the packet from the anyone else. That time we can use ingress and egress rule appropriately.
Yeah, sorry, Ramesh, but like for web, for this application also, like from pod 1 to pod 3, there both the rule, right? Request and response has to flow. Then only the web application will see the response on the web page.
Correct, correct. It should be. So you should have an ingress traffic. You should also have the egress traffic here for this one.
So then in what scenario we should not use egress? Because here I can find that we have to use both. Like ultimately our aim is to get a request and response, right?
Yes. So in the scenario is that you should only thing is that you should always have an egress open, and ingress is required. If ingress is required, let's say this is your pod, and you can keep the outbound traffic as it is. Let the traffic go outside this particular pod whenever you want. So don't block this one for the web server specifically, at least, but you can control from the traffic should come. You can control it from so that is source.
You are taking an example of three-tier architecture like web layer, app layer, and DB layer. So for that, any request which is coming from the external world, which is coming to web layer, and that will check whether the request is already there or not. If not, then it will go to app layer. It will check the application source code, and if that is already cached with some information, then it can respond to web layer directly. It should not go to DB layer. If no information is exist in app layer, then it will go to DB layer and it will fetch that information, that particular user information. It will again back to app layer and from there web layer.
Correct.
So the request is ingress from web to app to DB, and then egress from DB to app, and app to web and external world.
Yes, correct. Absolutely.
In this case, whatever Sundar said, both egress and ingress are not been blocked anywhere.
No,
Where
but
is that restriction?
Source we can.
I think the egress is blocked from DB to web because ultimately the record will be fetched from the app. Okay. So the egress will be from DB to web 1. It won't be stopped from web to app 1. Is that correct, Ramesh, understanding?
See, it is simple example that, guys, if you are let's say that I'll give one simple example to understand. My doors are open for everyone. My home's doors are open for everyone. This is one statement. What it means? Ingress is allowed. Anybody can come to my home. But second statement, I am saying that whoever is coming to my home should go outside as well. So my egress is allowed. This is second statement. So in this case, there is no network policy. Now I am applying a network policy. Only my friends, close friends should come in my home. Who is having a pass called as something, label called as this one. Nobody else will be able to come inside that. So I am not blocking egress at all. Egress is on.
Ramesh, but here
business requirement only business requirement.
Ramesh,
Only business requirement.
if you are allowing app to egress traffic to database label, but database also need to accept the traffic from app. Both way we have to define the rule. Then only it will work.
Correct, absolutely correct. You have to write the rule in such a way that this database will accept the traffic from the ingress traffic from the pod 3, and egress. It should also egress the destination. Pod 3 should also accept the traffic from the pod 2. That rule has to be added.
Just opening just having a one rule in app label it will not going to work. Hey, I have opened egress traffic to outside world or maybe database label, but we need to add another rule in database also. So we have a multiple network policy in that case, right?
Right. You need to write that multiple network policies.
So one question, if you don't mind, I think a lot of questions coming up where we are not, maybe we can architecture diagram with the two-tier architecture with a proper, not dev or prod, maybe a web tier, app tier, and a database tier, create a 3 namespace and try to see the workflow
No, see,
from the
I'll
outside. If we can have deployment and we have create surveys and how the traffic workflow will work in a real picture for ingress and out. Another question, maybe if you can think it of, it's a AWS is a security level, security group level, or it's a network NACL level, or I can apply this network traffic at the subnet level, means namespace level, or it will be applied only at the pod level, or it can be applied at the deployment level. I'm not sure where we have to apply this policies if you want to have global policies at the namespace level.
You tell me one thing now. I just deployed this policy. Where I deployed this policy? It is in default policy, right? So we are just working on the one namespace, default namespace. We have not touched to the multiple namespaces till now.
So that's what I'm saying. If you can create 3 namespaces, one is web, other is your database namespace, and third will be your then it will be much better understanding what 3 namespaces, and one namespace is tier 1, tier 2, and tier 3, like 3 namespaces.
My question, yes, I understood, Vivek, your concern, but only thing is that I hope that everybody has understood the concept which I have right now explained in the same namespace. How you can block the traffic or how you can control the ingress and egress traffic in same namespace, right? I hope that that is clear to all of you. So if you are having a questions related to multiple namespaces, I request all of you to hold the questions for some time. I will make it clear for you.
Okay, thank you.
Ramesh, before you implemented a network policy, so by default, before applying any network policy or creating any network policy, the ingress and egress, okay, both are allowed, right? There are no restrictions by default for any pod.
Correct.
Okay.
Let me take the questions, guys, please, if you don't mind, because
Ramesh,
Abhiram has a, let me
related
ask
to this one, related to ingress and egress.
Mhm.
So let's say I have a database server and an app server, and I don't want all the traffic to come to database server. I need to open up only specific ports. So how do I, let's say pod 1 need to communicate to pod 2, but not on all the traffic coming from pod 1 should not come to pod 2. Only traffic coming from certain ports, traffic receiving in certain ports should be allowed.
Yeah, that is possible. No problem. You can say this way. You are saying this way. Port. I can specify the port number.
Oh, okay.
Okay.
Oh, okay. Thanks.
Okay, let me take the questions quickly, guys, so that we can close it. If by default, if network policy not defined that the pod will allow ingress and egress from all cluster. Yes, Abhiram, that is true.
Okay.
Yeah, and is it okay to define the same name of label for different pod? No, basically, if they are having the same function, if they are from the same application and doing the same function, you should have the same labels.
Okay.
Right? So if they are having doing some different function, let's say in one application, you have service pods, you have deployment pods, or you have a database pods, you have some other pods also, config map pods are there. So there should be always one label should be common across them. So in case you want to work on all the pods, so that one label will work, you can give the multiple labels also, right? So labeling
should be based on the namespace, right? Not based on the label, right, Ramesh?
Common name should be based on the project, what type of the project that is, right? And the another namespace, another label should be based on the region or the function of that particular pod, that which should be. So if you want to do some action, make some action on the certain pods, then you can use it as specific label. Is that clear, Abhinam?
No, what I was
Ramesh, if we have
what I was trying to think is like, See, if there is a common thing, then we define based on everything comes in a namespace, right? But if the common, you're telling all will have same label. Rather, it should have a, it is grouped based on namespace, right? Not based on the label, right? That's where I was confused.
No, that is fine. You will see actually if one project is there and there are three environments of that project. So ideally what you are thinking, if it is a prod environment for one application, you say that this is my prod for this customer, right? Prod underscore Google. Let's say that way you will create a namespace and you will deploy all the production related pods inside that one. But inside that also, that will be common namespace, right? But inside that also there will be different functions of the certain pods. So you can additionally name them. Okay, you can additionally label them so that you can perform certain activities on the certain pods.
Okay. Ramesh, can you just put on the drawing board, please?
Okay, let's say that this is one namespace, and in namespace you have, let's say, sorry guys, 1 second. This is one pod. Okay, this may be your web pod. You might have another pods also in the same namespace, application pods, and some may be service pods, some may be database pods, like that. These pods are there. So there will be one common label to this pod, all pods, that is called as application is equal to prod, something like that. I'm just giving some name. But in that
This
one,
is
so
not the
all,
namespace name, right? This is just a label. This is not a namespace label.
no, this is a yeah, this is a just label. This is not a namespace. I can give the same label to this all pods, right? Look at this. This is one label. So in some scenario, I want to fire a query saying that please please increase the RAM or please increase the CPU of all the pods whose label is app is equal to prod1. So it will get implemented to all. Now another case comes like this one, that this is your let's say this is app is equal to db1. This is the another pod name I'm giving, and this is app is equal to db1. So these two pods are there from the prod1 application, but their function is app is equal to db1. Now if I want to do some changes in these two pods only, then what we can do, we can write like this one, say deploy this action or make a correction in this make the correction in the pods where the label is app is equal to db1. So then that particular changes will not happen on the app is equal to prod1 and app is equal to prod2. So common name can be given as per the project name, and another label can be assigned by using their region name or function name, so that you can perform the proper activities or actions on the specified label containers or pods. I hope that this is clear now.
Yeah.
Okay, thank you. Sumant, does that mean we cannot implement network policy without any label on the pod? Yes, correct. We need to label the pods, right? That is important.
Sorry,
We
Ramesh,
can.
Ramesh, one question. So you're saying in this example, what you are showing at the moment, app is equal to prod1. So app is nothing but a label. So can we have two? I mean, if you see, are we not overriding the label app is equal to product1 with app is equal to db1? So app is nothing but a label which basically is repeated for these two pods.
All pods.
Yeah, but for these two pods, it is overridden. If you see, you've got app is equal to db1 as well. So what exactly is the value of app now? Yeah, makes sense now.
Oh, okay. I
Yeah,
hope that this is not clear.
It's a multiple labels for that pod.
Right, huh? Understood.
yeah,
So
exactly. Yeah,
things will be
yeah,
different. Things will be different.
yeah.
Okay.
Cool.
Thanks for correcting it.
Cheers.
Yes, Praveen has answered that. Labels are the key point in Kubernetes. Okay, so Abhiram is asking, has from ingress has from then above ingress is. I have not understood. Abhiram, I think it is clear, right? Whatever you want to say here.
Yeah.
Okay. Those pods will be accessing each other. Bolan is asking. So your question is related to Bolan? Is something related to which pods? Bolan, are you there?
I was talking about the port prod and test. I was talking about the interaction between two, the ingress, like we configure the ingress from was coming from the prod to test one. Is it the same thing? But I got it. The same thing. Since you didn't block it, it should be open. Thank you.
Okay, you got it. Thank you. Abhiram, we never indicated number from pod 1 or pod 2. No. We will always use the labels. Yes, correct, Abhiram? Okay. If we put env is equal to prod, and then it will be applicable for pod 1 and pod 2. Yes, correct. I think that is clear, right?
Yeah.
Ranjit is asking network policies just like inbound and output rules in the AWS. Correct. That is correct, Ranjit.
Yeah.
Yes. Okay, I think Vivek, I have answered your question. Practical
No,
use case.
no, Ramesh. No, Ramesh. Let me counter the question. It is not equivalent to network. It is not equivalent to security group, which is in AWS. Because if in security group, you need, if it's inbound is allowed, or outbound is automatically allowed in AWS. Whereas you have a NAC
You can
and
also
NACL.
control that in security groups.
Understand? No, you by default it's a stateless, right? And the stateful is your NACL on the security group level. It is basically on subnet level. So when the traffic is coming from the internet gateway, it will go to your NACL. NACL will see there's an inbound and outbound rule. There we have to specify whether it's ingress or egress. But once it's passed through that, it will go to the security group, and the security group is on the VM level, EC2 level. So in there, you can define whether it's inbound is allowed, but outbound is always allowed. So that is why question is over here. If we talk about subnet, whether the namespace is equivalent to your subnet, let's say. That is why I'm asking you, Ramesh, if you can design the whiteboard might be better fit for us. One is your public subnet, one is your private subnet. One is public means your web servers, and private is your DB servers. And in DB you have multiple pods, and your public subnet is your web, which has the multiple pods. Now the traffic is coming from the load balancer to the ingress controller and towards the deployment, which is your web deployment. One is your DB deployment. Now see the traffic flow. In that way, you will be better understanding if we can do that.
Okay. Now I'm not going to explain you something about what is the access control list in the AWS and what is the
No, I'm not asking about.
that.
So I'm just
fine.
trying to understand the ingress, egress, how it works. It is working on the namespace level, or it works only on the pod level?
So it works on the pod level as well as namespace level. So I can completely block the.
If we have two namespace and each namespace has a label called, let's say you have a two namespace. I'm just trying to understand that one is your namespace is, let's say.
I will explain you that namespace. I have not taken the example of the namespace. If you don't mind, please, can you hold that for some time?
Okay.
Yeah. The reason is that I will just complete this question and we'll go for the namespace only. And I want to explain you that if there are two namespaces, then how we can block the traffic between the namespaces. Is that fine?
Ramesh, Ramesh, just to be on the same page. So currently you have not explained anything. I mean, you'll be covering namespace in the next session or next lecture. So
right
currently
now,
what you exactly right now means after picking up all the questions. So currently what you have explained so far is basically default, right? For default namespace, how do we apply network policy?
Right. What I was trying to explain you till now that in the default namespace or in namespace, how you can control the flow. Okay. Ideally, all the pods are talking to each other. How we can control
Correct.
them? That was my, and making you understanding about the ingress and egress words.
Correct. All right. Yeah.
Right.
Cheers.
So,
Thanks.
Amit, this is at a pod level name network, but again, namespace level you'll cover later, right? That's how I understand, correct?
Just give me some time. I will just do that one. Don't mind.
Ramesh, like extending a little more, so can we do the same for our nodes? Like, is there any possibility in Kubernetes that we control the traffic between nodes, like within the namespace and outside the namespace, and also the nodes? Is that possible?
We can use the IP blocks for that one. Node specific, it is not there. Okay, in the Kubernetes, when you are deploying, so then it comes along with the different traffic rules, right? As not a network policy rules for the pods. So these rules are only for the pods.
Okay.
Okay, what could be the scenario where you really want this on a node level is what I'm trying to think.
Yeah, so see, I have a namespace with a web server and application and the DB, and web server is in one node and DB is in one node and the application in the third node. So that
You
is
still
the
can use,
scenario.
yeah, you still can do what Ramesh has just explained rather than restricting it on a node level. Your pods will have
No,
the
instead,
labels.
yeah, I got it. So instead writing, see, I have 100 pods or like different pods. So instead writing network policies between pods, if I control one place where two nodes were trying to
Okay.
communicate.
Actually, that will be a little bit complicated stuff. See, basically, if you see pods deploy, when we do the deployment, any project deployment, it gets across the namespaces, right? So basically, whatever we are discussing, the network policies, which is on the pod level basis, where we can use the IP addresses, where we can use the port numbers, and we can use the pod labels as well as namespace labels. These are the 3 to 4 parameters we can use to control the traffic. But for the node basis, no, it is not there inside this network policy document. Okay, not a network policy concept, right? So I'll just check out for something else, because then there's a firewall, other concepts are there that we can use, but not at the pod level.
Okay, Ramesh, got it. Thank you so much.
Okay, so practical use case on ingress and egress and blocking. I hope that is clear, Abhiram, now.
Yeah, I mean, at a pod level, we are telling, but again, when we say practical, like, is it at a, those will be like a app DB? That's how I have to think it, or?
Okay, no problem. Just hold on for some time then, please. Okay, then Sumant, does ingress carries high priority compared? No, both of them are having the same priority. Depending on how you write a rules, the same thing is there. There is no such priority rule. I think Piyush has answered that. Can we put more complex conditions and or operator while adding a policy label is prod and okay, I will try to do that, Anush. But if you make it a little bit complex, then it becomes a little bit difficult, right? So
So example was, we give multiple labels, and if I just want to filter out based on few things, let's say I've got 3 pods. Pod 1, which has got a label as prod 1. Pod 2 has got labels as prod 1 and prod DB, and I've got another pod 3 which has got prod DB and prod 2. So if you see, they're mixed and matched. So can it be basically a little bit more complex using operators? I mean, it's just a question whether we can use operators in this or not. So we can sort of apply rules based on operators like and or.
See, basically, in this pod, as per till now, whatever I have written the policies, I have not used the operators. I have not seen that as well.
Okay.
So, but I will check in case in the complex nature also if there are operators are used, right? But I will try to check.
Okay. Perfect. Thank you.
if you have a policy, one is ingress and other is egress from pod 1 to pod 2, right? Let's say pod 2 to pod 1 is also has the same ingress to egress, means pod 1 can communicate to pod 2 and pod 2 can communicate to pod 1. We have that policy, let's say. Now we also has in a same network policy, we also deny and allow, right? Let's say first we allow and then we have a deny the policy to pod 1 to pod 2. Which will work, with deny or allow?
It supersedes earlier one. So it's like this one. If you have, let's say this is policy 1, then you are writing another policy 2, then there is a third policy. So first of all, it will check this policy. If it is true, if it satisfies the condition, okay, then it will not go for the second one. If it is a false, then it will
there is
go
a
for
priority, like priority number, right? High priority will get the first, the lower priority will get, it allows, then after that nothing will be works. Like normally the rules are defined in priority level, right? Like 100, 200, 300, whatever, like that priority numbers. I'm not sure how it will work here.
No, rules are written in the, if you are talking about the IP tables and firewall related rules, they are written in this way only. With the, the number of rules are there, let's say 100 rules are there. So if any traffic is coming, then first rule will be checked, then second rule will be checked. If the first rule itself is satisfied, then it will not go for the second rule. So that is the way it is.
Correct. So same thing I'm thinking. Yeah, same thing I'm thinking over here is in network policy. If you have a same network policy, but you have two stanza in the same policy, one is allowing, other is denying.
It is
right?
union.
That's a pod.
Union. It is a union. That is what word I used here. If there are multiple policies are written, it use the union combination, which is the common between all the policies get applied.
Right. But I'm not. I understand. But let's say I'm talking about pod 1 to pod 2 in the same default namespace. Now pod 1 has a network policy. Pod 2 also has a network policy. Pod 1 has a network policy, ingress and out and egress, allowing and also denying. Same thing, but only allowing first and then denying later. You understand what I'm saying? So allowing will be apply first. That means it's allowed. So it will not go to read the deny policy. That's what my understanding is.
Right. So if the first condition is set, then second condition will not be read.
And Ramesh, what Vivek is correlating with Azure energies, priority based energy rules, right? That is from that is from the NIC level energy or subnet level energy you are talking, Vivek. But the one Ramesh is showing inside the like OS level, he's doing IP table or YAML level.
Correct. I'm talking from that level. So what is his question right now is saying that you are using the ingress. His question is like this one. Okay. And then another one is egress. Okay. And this is what his question is. Correct. So what is happening here? You are blocking the first of all you are writing ingress and then you are writing the egress policy, and none of that will work.
First of all, I think
in the first stanza, ingress allow all.
Allow all, right? So you say that here allow all.
So the first stanza you have a policy ingress, right? The above the parts. I don't know.
If I use this one, it will allow all.
The first one ingress egress allow all, and the second ingress egress deny all.
No, that way we cannot write the policy. This is the way we can write the policy. This is my ingress rule, and inside that I can write a rules, and egress is I can write here some rules there. So for this particular pod, for this particular label, I'm writing one ingress policy and one egress policy. This is the way I can write egress first and ingress later. That is okay, but there is no combination of that kind of stuff we cannot use. Are you getting it? What I'm saying? Now here all pods are allowed.
This is the default one, right?
This is the default one. And if you write here,
ingress if you allow and egress if you block for all, okay, doesn't make any sense.
Right, it doesn't. Though that means traffic will not go away. Only thing is that priority, which one will be accepted first. So whatever comes first here in this case, this ingress rule will be accepted, and then egress, it will go for the egress rule. Is that clear?
Okay,
Yeah, but
okay, thank you.
ingress if you have allowed from all the pods and egress if you have blocked for all the pods, then
No
it is not going to work. Why? Because the acknowledgement will not be there, right?
Yes, no communication will be there.
Ramesh, so one more thing. So flower basis means like we are allowing it, right? When it is square basis, we are not allowing.
Yes, correct.
So in the earlier case, it might be a fire and forget sort of scenario.
Which one?
The previous one which you showed, like ingress allow and egress is blocked. So that could be a scenario for the fire and forget, receive and then you mention the response.
Yeah, basically no response will be received. It will be completely blocked.
So that can be used archival scenarios. The data which is trying to inject into a
maybe logging and all those stuff. Yeah, fine.
Exactly, right. For the application purpose, it should not be the case. We need to define the revert text. Sender and receiver should be acknowledged.
My dear friends, let me put it in a very simple language. If this is my one pod and this is my another pod, let it be anything, guys. Here one rule is simple rule, and please follow that rule, what I'm saying here. If ingress is allowed inbound, okay, in IP tables it is called as the input. Okay, input, inbound and ingress, these three words are same. If you have ingress allowed, so all traffic will be accepted, all the packets will be taken inside the pod, second pod, maybe virtual machines, pod, container, whatever it may be. You name it, it is the same rules. But another important statement I am again making it, and this is I think third or fourth time making it. If any traffic is going out from this one is called as egress, and if you block the egress, even if anybody tries to access this one, even though there is ingress traffic going towards the another pod, but egress is blocked, there won't be any communication. In any scenario, for any scenario, this is not perfect. This will not work. There is no use case for this one where incoming is there and outgoing is blocked. There is no scenario such.
Correct. Then what is the use of keeping the data into the pods?
There is no use of this one. That is what I'm trying to tell you.
Correct.
So I think, yeah. So there are two pods are there. So we want to communicate with each other, right? We want to restrict the communication, or we want to just allow certain communication. So for that purpose, we have to use ingress and egress appropriately. So somebody says that, look, I don't want to talk to, there is one more pod here there. I don't want to receive this pod says, I don't want to receive the packets from this one. I just want to receive it from this one. And when I'm sending the packet outside, I need to only send the packets to this one. I don't want to send the packets to this pod or maybe another pod.
But Ramesh,
right? So in this case, you have to use the
I don't know about Kubernetes, but you need to deny first and then allow first. That's the best practices always, right? Whether it's a cloud or Kubernetes or on-prem. The first deny all. Everything is denied. Means nothing can be communicated to each other.
Right. You have to deny all first, and then you have to open one by one. That is correct. Everywhere this policy is perfect. Okay, I hope that let's move ahead, guys. Otherwise, our syllabus will not get. But I hope that you are getting it. This is a good discussion going on, and I
Correct.
hope that these layers are getting open.
Ramesh, I have one question, but I don't ask now. End of the class, I will ask.
Yeah, please. Let
You
me
can.
just finish. Couple of questions are. Oh my God, there are so many questions. Okay. 4 to 5 questions are there. Just give me 5 minutes, guys. Let me finish this one quickly because I want to respect everybody's question. Can you show the configuration communication of both ingress and egress? Can we put more complex? That's done. Can we show? That is not done, right? Only thing is that I have not. I will check it in case there is a complex parameters operators are used. Can you show configuration communication of both ingress and egress using YAML file? I think I have shown you, right, Amira? Yeah. I hope that you got the real-time example also.
Okay.
Yes or no, Abhiram?
Yeah,
I
yeah,
hope
yeah.
that you got. Yeah. Yes. Trilochan Raj, can we apply the rule on the basis of IP or domain name? Yes, we can apply IP. IP we can use it. Yes, we can use it. Yeah, Piyush has answered that question. Anirban is asking for blocking the calls between two ports. Would it require to block ingress, egress in both ports? Otherwise, it can have incoming and outgoing from one port. Whereas, Anirban, can you just ask the question, or is it clear now properly? Doubt is cleared.
Yeah, actually, I'm asking that if one pod has a blocked ingress and egress rule, and other pod has an open ingress and out means egress rule, then how come the means network policy applied?
No,
Means
if one pod says that I have blocked for all, it will not be. It will be completely isolated from the all other pods.
Okay, means another pod wouldn't require for that means declaration for that
No,
mentioned pod is already blocked.
no, not required. Not required. You don't have to say anywhere. That communication will completely block. Even if you write any other policy, that will be completely blocked because that pod says that I don't want to either. The ingress is also blocked and egress is also blocked. That time, this scenario will occur.
Okay, got it, understood.
It is completely isolated. Yes, Rishi, we can enable the ingress and egress at port level also. Yes, we can do that. Surendra is asking, if we apply rule based on IPs, then every time when you redeploy port, IP addresses will change. So in that case, rule will not apply. Yeah, we have to use the rule on the something called as a service based or yes, that is true. Cluster IP based, we can use it, Surendra, in that case.
So clustered IP, and
Yeah.
in that case, so okay, I got it. Okay.
Yes. Okay. No, see, Anirban, what I'm talking about, saying that if you are asking a good question actually. So when I initiate a ICMP packet, okay, that is ping command. So my packets are reaching to this place. That is ingress is allowed. Egress is allowed from this machine and ingress is allowed. But if you have blocked egress that do not allow the outbound traffic, then this pod will not send or transmit the packets. So that is called as a blocking the acknowledgement. So if I am talking to you and if you are not responding, then there is no communication, right? It is called as a blocking the traffic. So even if I 100 times I say hi, but you will not respond, that means there is no communication, right? So that is egress. So you can do that one. So that is called as acknowledgement. So
Ramesh, sorry, just
for
quick one
TCP
here.
also, for TCP also there is a traffic, and for UDP also you need to have the some acknowledgement, otherwise there will be problem. Yeah.
So Ramesh,
Anand,
let's say we have got HTTP server running on this and just ingress is allowed. And what would be the response of this HTTP request? Will it, at least it will give the response of this HTTP request, right? Or even that will not be allowed?
no, timed out, request timed out at the client side.
Okay, so basically then it's good for nothing. I mean, if you have HTTP server, you can't even get any, you can ping it, you can send a request, but you will not, and HTTP, when I say HTTP, it is a synchronous call and you are expecting a 200 response back from HTTP and you won't
Right.
get it because egress is not set here, right?
Yes, correct.
Right, okay, thank you.
Okay, so yeah, I hope that yeah,
one
please.
last thing. Yeah, so we are executing the network policies.yaml file, right? So like how in the background, like how it is, like where it was trying to set it in, like whichever in master, it will store in which place and how it will be checking,
will
like
be
whenever we get a ping.
So basically, this is something which is gets stored in the etcd database. So first of all, where it will be stored? It will be stored in the etcd database. It is available inside the master node, right? You can see that kubectl get
Yes.
pod -on new n kube system.
So when
-o.
pod 1 is trying to ping pod 2, so it will go to the control will go to API server and from there to etcd, and there it will check, and then if the network policy is proper, then it will route to pod 2.
Right. No, once this API, we are using a API server to deploy this policy. Once the policy is deployed, then the traffic is coming from the service end, right? Once it is received by the service end or from the node port towards this one, right? Then the IP tables which are controlled by the kubelet or kube proxy inside each worker node, that will control the traffic. So
But
basically,
Ramesh, if
IP
you have a
tables
cluster IP, if you have a cluster IP service, and I know that this service is basically goes to this deployment, which is my database deployment, right? DB deployment, and this service is cluster IP, right? Because it's a backend, not front end, but backend apps, right? Database. That's as a cluster IP, right? And now you have on top of that you have web namespace, or maybe rather I should say a label. I don't know. That web space has a web label has multiple web pods. That has a node port IP. Node port basically, right? The service kind is a node port. That's the scenario you have. Now you need to control your traffic. That okay, the cluster IP means I don't want to specific port wise network policy. I want to create a policy which is basically belonging to the cluster IP level, so that all the pods or all the deployments under that pod should automatically block from the outside world, right? I mean, I don't know. I'm just trying to understand. Maybe inside world, not outside, but let's say inside also. I don't want to restrict the policy on the service level.
Okay. So basically, these three services, service types are cluster IP address, load balancer, and node port. Right? Any one you can use one of them, right? So if whenever you are creating the network policy here, in this case, if this is your cluster, and this is cluster, right? And you are creating a network policy. This network policy is a namespace resource.
Okay. Say it again. Network policy is a namespace resource.
Yes.
Okay.
Okay, network policy is a namespace resource. I can deploy this namespace resource. I can show it to you also here, whether it is a namespace. You can how you can check it, that you can use the command kubectl API resources less, or I can use command grep-i network policy, right? And it is true, right? Yes, it is a namespace related component. Okay, so when it is called as a namespace level policy, see basically IP tables take care of the rules. traffic which is going from one place to another place, right? From the if the pods are placed, this is a namespace, and this namespace is spread across the 3 worker nodes or 2 worker nodes, and you have certain pods running. Couple of pods are running on the worker 1, couple of pods are running on the worker 2 for the same application. I'm saying same type of the application is there here. This is my one pod, this is another pod, but they are the same, they are identical in nature, and they are talking to any type of the pod, any type of the service. It can be load balancer, it can be your node pod, or it can be your load cluster IP address, right? So once the traffic comes here, okay, then this traffic is forwarded to the corresponding pods which are running in the worker node through the kubelet, right? And through the service kubelet, and the kube proxy is present inside the each worker node, and it takes control of the traffic forwarding. So if that pod is there, and it there is a network policy, so it will be checked across this particular kube proxy, and this kube proxy will help you to understand where to forward the traffic in that worker node. If the traffic is forwarded in this one, then the kube proxy of this worker node will try to forward the traffic appropriately. Similarly for the another worker node, right? So IP table is the one of the thing which is used to forward the packets from one pod to another pod, or maybe from the one port to another port with the help of kube proxy on the specific worker nodes. Is that clear? I hope. Yeah, Nirban? Yeah. Thank you. Yeah, thank you, Anuj. Yes. Calico supports this policy, Arun. There are 5 to 6, or maybe more than that. The CNI policies are there. They definitely support this kind of structure. Arun, is that clear?
Yes. Yeah.
Okay, thank you. All right, so let's move ahead, guys, and we will discuss about the another stuff. So let me go through the slides, guys. I think that will help. Let me just see this way if I explain you whether it will be helpful to you or not. So, okay, so this is deny all ingress traffic. So in case you want to, let me show you here. This is we have seen already. So target pods with the app is equal to web level. We have discussed this, right, guys? So this is containers are there, and you have the pod name called as app is equal to web, and you are saying this is ingress. So whoever is trying to connect to the pod whose label is app is equal to web, the traffic will be completely blocked. This is what I was trying to tell you guys. Now allow all ingress traffic. If you want to allow ingress traffic, guys, you can use this one. If you want to allow the names, if you want to allow the traffic from the specific namespace, you can use this one. So if you say that this is the pod which is in certain namespace, and you all the namespaces should access this particular pod, you use this, right, flower bracket. So empty ingress rule allows traffic from all pods in the current namespace as well as other namespace it corresponds to. I hope that this is clear statement.
Yes. So this is much better because we have a namespace selector here also. Pod selector and namespace selector.
Yes, this is what I wanted to explain. Okay, let me just put the date properly. The manifest files having empty the spake.ingress. Let us go ahead. Yeah, clear. Now we will be deploying this one. I will be showing the practical. Don't worry about it. Allow to and from the same namespace. So we have seen this, right? From the same namespace. We have seen this exercise. What is this exercise? Look at this. Pod name API allow. This is the pod selector. This is the match label, and we are writing this is ingress policy from which pod where it will access the traffic from all the pods whose label is called as app is equal to bookstore, to whom this role is equal to API. So this is something which you can see, guys. This is another twist. I think Anuj has asked me this question, right? How if I have a multiple labels, app is equal to bookstore and role is equal to API. So I can have this, I can have on the same pod or I can have on the multiple pod also, right? This
Yeah,
labels.
that's right. Yeah.
Right. So on this one, the pods who's having a labels called as app bookstore will be able to access these pods who's are having these labels, right? This is ingress. Cool. Now this is in the same namespace. It underlines that it is in the same namespace. Let's try out for the different namespace. Okay, guys. Allow to and from the namespace selector. So this is the example that we would like to see. Look at this. So we have the three namespaces here. One is the secondary, another one is a default namespace, and third one is a bar namespace, right, guys? Look at this. Bar, default, and secondary. And in this one, you have any pods, but in the namespace called as a, there is a default namespace, there is a pod called as app is equal to web. What you are writing, what you are saying that, see, this is the network policy definition, and we are saying that namespace is secondary. So for this namespace secondary, we are writing this policy. What is the name of the network policy we are using? This policy. And what you are saying that the pod selector whose label is app is equal to web. So this is the app is equal to web. What is the type of the policy? Ingress from namespace selector. So what is the meaning? Curly, this particular bracket is nothing but allow all, right? So from all namespaces, what should be accessed? It should access the pod whose label is app is equal to web. Are you getting it, guys?
Can you explain the second?
Ramesh,
Yeah,
one second.
I am going to explain it. Sure, no problem. So this namespace default is having the pods, one pod whose label is app is equal to web one, and we are writing the policy for this one, app is equal to web one. And what we are saying that allow access to the pod whose label is app is equal to 1 from the all namespace. Right?
Yeah.
Correct.
Yeah,
So
got it.
right? So no other pods will get connected to it, right? So if you want, we can deploy this one, guys, but let me see if I have something else to show you. So another one is, this is another one. So we have again this namespace called as a whose label is dev purpose is equal to testing. This is a label. I don't know whether you are able to see it or not. This is the namespace whose label is equal, dev namespace is there, whose label is purpose is equal to testing. There is a namespace called as default where app is equal to web, and there is a namespace called as a prod whose label is purpose is equal to production. And what we are trying to write, this is the pod selector, that is okay, have a ingress traffic for the pod whose label is app is equal to web from namespace whose label is purpose is equal to production. So you will not have access from this one, you will have access from this one only. That is a very easy way to write. You can just write namespace selector and just write its label of the namespace, and automatically it will pick up that, guys, right? It will allow the ingress or egress. Okay, guys, so purpose
here
is the
it's
key.
Ramesh, only
And
from is
production
written. Huh? So the from is only written now, so you don't require write to, right? I mean, this only from word is there, right?
for ingress is the from, for egress you have to write to.
Yeah, but again, yeah, in the same property file, you don't write from and to, just that.
Yeah. No, under the ingress you don't write it. I can use egress and I can write to here. I can write ingress and egress, both policies in one network policy, both type of the policy in one network policy file. Okay.
Ramesh, one thing. So first, in the first YAML file, so there is a namespace secondary in metadata. So what does it mean? So
It means that even though your namespace, you are writing this network policy in the secondary namespace, but still it will check all the namespaces, right? Because we are giving the namespace selector is a curly bracket here. Curly bracket is nothing but it will check all the namespaces. That's it.
okay, so this network policy belongs to the secondary, not for the default.
No, not for the default. This specifically will
But
get deployed on, yes. Correct.
but it is for, but we are writing that network policy for the pod which is available on default namespace.
Correct.
Okay.
Ramesh, can we add the namespace selector and the port selector in the ingress rule simultaneously?
Yes, you can do that. I think we should have this one here. Yes, it is there. This example is there. Allow traffic from specific ports in the namespace. So you can see here, this is the ingress from namespace selector. Okay, so choose all ports in namespace. Match label is team operation. So this is my namespace whose label is team is equal to operation, and inside that it is selecting the pod. So please allow the traffic to be flown to the pod whose label is app is equal to web from the namespace selector whose label is team is equal to operation, and inside that if any pod whose label is type is equal to monitor.
So multiple selectors are allowed in network policy.
Yes, it is allowed. Yes, it is allowed.
So this type equals monitoring is nothing but a label. Sorry, label. Yeah.
Label. It is a label. Yes.
So if there is no pod selector matching type monitoring, then it won't do, right? It's an and or.
See, question is like this one. First of all, it will check the which namespace is there, how many namespaces are there, right? And once the namespace is found, let's say there are two namespaces which is having a match label called as a team operation. And once this is a condition is true, this is 1. And if this condition is false, this is 0, then you will not get the output. That means it is ANDing.
But then even though you don't have pod selector, okay, still it will allow the traffic from the namespace selector, right?
Yes. If you don't write then all the pods from this namespace selector will be able to access. But since you are writing again one more policy here, that is a problem.
So that means AND condition is going to be applied here, not OR.
Yeah. And it is AND, right? It is AND.
Yeah, means if the last one condition is failed, then the whole policy will be failed.
Right, correct. Yes.
It's like a double filtering.
Correct.
Ramesh, just one quick question. So at the metadata level, you have mentioned namespace is equal to default, but we are applying this for namespace
secondary
for a default namespace, right?
Right. So this policy is getting deployed on
default namespace.
Default namespace, right? But actually, then whenever this particular app is equal to web will be from the default namespace, if this particular label is there or this particular pod is there whose label is app is equal to web, then this ingress policy will work. Otherwise, it will not work.
Okay, all right. Yeah.
What is the significance of this namespace default? If you are specifically mentioning pod app is equal to web, okay, then what is the significance of this namespace is equal to default?
So this pod should be available inside this namespace. Then it will make a significance. Otherwise, it won't.
So
then in the previous example, yes.
So without having this namespace is colon default clause in this network policy, this can't be defined. The restrictions for incoming traffic for the pod app is equal to web, can't that be defined?
Right, I understood that one what you are saying, but wherever this particular policy you will try to deploy by using the kubectl command, you need to run in some namespace. Either use default or use somewhere else. but that particular namespace should have this pod.
So that
So in
means
that
for
case, your examples, the example you gave before in the previous slide should not work because our namespace was in a different namespace and this network policy was in a default namespace.
Which one
can
you
we see the previous slide? Let's see. I mean, what
I got
mean,
I got you have pointed out, guys. I know that one. Yes.
But it was namespace selector to everything, right?
Yeah, this will
Maybe
not
that
work.
is the reason.
yeah, this will not work. Why? Because the
Yeah.
namespace is secondary, where you don't have any
Yeah.
pod with name app is equal to web in namespace secondary.
This will not work.
I think
Ramesh, I think we should implement this practically.
match with
Yeah, I'll just implement it. I will take one example once you come back from the break, and I will definitely take it. Okay, because I will just show you the namespace selector example, and then we'll go ahead with the another topic once you have understood properly. Okay.
Ramesh, I have a quick question before we take the break. From the default namespace, right? If you have many ports with the label app equal web, that means with the network with this network policy, all the ports gonna be allow the ingress traffic from this namespace and this port selector, or it's gonna be from only one port.
No, this is basically for the pods, right? Which is inside the see, as I told you earlier, this particular network policy is the component of the namespace. It gets applied on the namespace. Okay, so when we say that this is the pod selector called as app is equal to web, if this pod is there inside this particular namespace called as default, because you are deploying this names policy on this default namespace. So what you are trying to do, you are trying to say that even if the traffic comes from any namespace, right, this pod should be available inside the namespace called as a default. Are you getting it, Bolan?
My question was, if we have many ports, like 2 or 3 ports with this label, with the equal apps equal web, that means the network policy is applied to all those ports, or they're going to be on only one port?
In the same namespace you are asking?
Yes, in the same namespace.
Yeah, it will be applied on all ports then.
Okay, thank you.
Whose label is app is equal to web? Yes, correct. Good. Thank you guys for asking these questions, but make sure that as Dan says that we should go back to asking the question on the chat. Anyway, but thank you guys. I think we should take a break now, and once you come back, or should I give the example right now and take a break? What do you want?
Let's take a break, Ramesh.
It's better if you give example and then take a break. It doesn't take much time.
Yeah, even I was about to, because we are in the same.
Yeah, take the example. Yeah.
Okay.
What is good for you, Ramesh? You are dealing with 50 plus people, so think about that. Yeah, makes sense.
No, I need to take a small cup of tea now. I'll take a break and I'll come back.
Yeah, maybe tea with vada pav, I think. Yeah.
Yeah, sure.
Ramesh, thank you for your patience. Actually, I really, impressed with your patience with such a large crowd you're managing. Thank you.
Exactly.
I think
I really
we can
appreciate
call
that.
Ramesh as Mr. Cool now.
Yeah,
Yes,
I need to
Mr. Cool, Mr. Perfect.
You guys, then what will happen? Nothing will come out of this session. If I start scolding on you, then you will refrain from asking the question. There is no enjoyment, then there is no fun.
Or we might ask more questions if you scold Ramesh. It might go the way around.
Let's see the questions. I'll start asking the questions then. Okay, thank you.
Yeah.
Okay, thank you guys. So let's stop the lecture.
This conference will now be recorded.
Sorry guys. kubectl. Yes, please start the recording. kubectl create namespace called as web and dev, right? This is what you want, or db? No, it doesn't work this way.
So web app.
Okay, friends, so we got 3 namespaces. kubectl get namespaces. You can see there are 3 namespaces now. There is one more namespace, kubectl delete namespace, which I don't want. I request everybody to please give the attention and ask the question at the end only, please. Okay. Let me create the kubectl run app 1. So let me create the web1 pod whose image is equal to httpd, or let's use nginx only because nginx, and then let me use the labels is equal to, what is the label you want to use? Namespace is equal to web. Okay. And anything else is there? Yes, namespace is equal to web. So we want to create the pod web1 whose image is this one, label is this one, ns is equal to web, and in the namespace called as a web. So it is created. Then let me create it into app1 app namespace is equal to app, and okay, so this is my app1. So this has got created inside the namespace called as a app, and third one is a db. So namespace is equal to db. This is the label we are giving, guys, and okay, all right, and this is my db1. So these are the pod level labeling. But I want to label the namespace also, because if you see here, kubectl get namespace hyphen show labels, you will not be able to see the labels of this particular namespaces. So I would like to provide the namespace to this also, kubectl label namespace called as web. What namespace should I should give here? That is called as something different, right?
Maybe
Server.
WebNS.
Okay, I will use this one. It's okay. Server namespace, right? Server namespace is equal to, yeah.
Yeah, that's fine. And app
Okay.
NS and dbns.
App ns label namespace called as app, and this is my dbns. Okay, guys. Oh, I hope that everybody is comfortable with this. Now let me see. Show labels. Okay, we have this app ns, dbns, and web ns, and as well as we have this name labels ns is equal to web, ns is equal to app, and ns is equal to db for the pods. So let's go to the drawing board to understand the concept. We'll go according to the diagram, otherwise it will be confusing, guys. So we'll create a diagram what exactly we want to do, right? Because I am not taking any example from the activity guide or something like that. I'm just showing it right now. So this is my cluster, and inside the cluster I have 3 namespaces, right? And it has pod called as, what is its label? Pod named as web1, and the label is ns is equal to web, right? And this is in the namespace called as what is the namespace we have given? Server is equal to, right? This is a label name. Server is equal to webns, right? And its namespace is equal to web, right? And similarly, we have done it for okay. So we have app1, and this is my app, and this is my db. Sorry, guys. This is online now, so sometimes it gets db1 and its namespace is db, correct? And this is my appns, and this is my dbns. So these are the names of the namespaces, guys, right? So these are the labels. Okay, so first of all, what we will do, we'll concentrate, focus on this pod, this namespace. So what we'll do, there are three namespaces. We'll write one policy, first policy, and that policy will be no one should be access this namespace. So we'll deny rule at the namespace level, right? And then we'll allow for only one, and then we'll go for the second one. Okay, guys. So this is the way we will do it now. So first of all, first criteria is that we block all the namespaces. So no, right now what is happening, all the pods will be able to access to each other, and we don't want to demonstrate that because it will happen. And now we will block them. So let's do it for the namespace called as app. So I'm here and Kubernetes.
Uppercase.
No, not slash, it is inside here. Okay, cool. VI namespace, not, what is that? Network policy, right? Network policy ping.yaml. We'll use this one. Okay, so we'll use the ingress. Okay, let me delete this case because we don't want to work with this one. So what is my match label of the node selector now? Namespace selector, right? Namespace selector match label.
I think it should be small and Ramesh. Namespace.
Sure, no? Let me check out once. Yeah, namespace selector. Okay. So then we will use the in the ingress rule. In ingress rule, we'll use this one because how will test the otherwise the ping command, right? So let me try out this namespace selector, and this is small s, and this is a small n as well.
I think S is.
No, that
Oh,
is small.
sorry. Yeah.
Match labels, and what is the namespace label, guys?
appns. Or
Are you sure? I forgot it again. What is the namespace I have given for the name? Okay, server is equal to appns, right?
I think it's
That is,
appns.
yeah, this is the way, and this is correct. Yeah. And now what we'll do, I will write the ingress rule policy types exactly below the policy type ingress colon, and what you want to write here, let's use empty. So what will happen, this will completely deny all the communication, right, with this namespace selector. So let me try to deploy this. But where I'm deploying this one, I'm deploying in the default namespace, right, guys? Okay, we'll deploy the default namespace, but see how it functions, how it behaves. Let me save this. kubectl apply -f network policy ping.yaml. So
I don't think it will allow namespace selector at the beginning, Ramesh. I think it should be pod selector, and ingress rule we should specify the namespace selector.
Okay, so it is a pod. What was that syntax? Pod.
Pod selector.
POD. Only small one is there, right? POD.
Yes.
And here then you have to use the what is the name of that? Namespace is equal to app. That is what we have used, right? And inside the ingress rule, we can write that one. I can use dash from.
Orange. Ramesh, what is the level of the pod?
Label of the pod is namespace is equal to app.
Actually confused. That's fine. I can understand Ramesh here, because you should not give namespace pod name, pod label as namespace. That's the confusion.
1 minute, 1 second. Let me check out, guys.
You are right. You are okay. I mean, I can understand that you are giving the pod label as namespace equals pod. I understand, but you should give that, some different namespace itself value. A key name is itself confusing.
Okay, no problem, no problem. I think I have used the right namespace, right? If I'm not wrong. Label kubectl get pods -- show labels from -n. What is the namespace now? App, right? This is ns is equal to app. Perfect, right? No problem. Okay, so from, let me use quickly, guys, from namespace selector. Do you have that file? Because I'm not able to get that one.
Okay. I think Piyush has pinged something in the chat.
Yeah, because it will take time otherwise, right? I think I need to type it. 1 second. From namespace. Right.
Ramesh, I think.
Ramesh, I think I was looking up at kubernetes.io and they have pod selector and then some brackets. I think, do we have to mention it from there? Because it says ingress : and then dash from : and then dash and then name selector and then the match labels followed by end user and then -pod selector and then role. What?
I think this is very simple network policy I have written. I think this should work. What is this policy? Policy says that this is ingress policy for the pod selector whose label is app.
Correct.
What I'm typing that what from which one from the what are the rules you want to apply. So ingress rule is that from namespace selector and just blocking it. So what is the meaning of this one? No, from any namespace if you try to, from any namespace pod if you try to access this pod which is inside this label, it will not work. Okay, so let me deploy this one. Let's see that. So I'm trying to simplify this one. I'm trying to simplify, nothing else.
Thank you so much, Ramesh.
Yeah, but it is giving me error.
Ramesh, I think if you give this task to us as a homework, that is going to be best practice to us.
Okay, let me finish this one and then we'll go ahead, guys. Just because somewhere it is policy types English, because I have taken the task, I want to complete it.
Ramesh, I think it's flower bracket, Ramesh. You give square bracket.
No, flower bracket is for all, allowing it. I don't want to allow it.
Okay.
No, error says right. It should be in a map instead of array.
Right. So somewhere there is a small mistake. Okay, and from it is also coming fine. Okay, so what is the error this time? Network policy space ingress from space type of the okay, got array expected map. Okay, guys, let me pick up the file from the this one only. I think it is not available in this one, but let me pick up it from the what this Piyush has given me. Let me check out so that we can copy paste it fast. But this particular is for the not specific namespace, right? If I'm not wrong. Okay, guys, I will do that one quickly. Don't worry. Okay, this is kind. Metadata. Again, I need to do the namespace is equal to default, then specification, pod selector, match labels. Okay, then the role will come, then policy types.
Role equals roles DB is a label, right?
Right, we have to change this one. Let me just arrange it properly, then I will change it. Then ingress, then from. This is for IP block he's using. CIDR. Except I don't want to use this actually from.
Ramesh, I think we can create a YAML file from the imperative method.
Yeah, we can create that as well. 1 second.
Ramesh, I've shared one sample YAML on the chat window. Okay, I think you were copied from there. It's
Yeah, I
not
copied
properly
it.
aligned.
Yeah,
Yes,
it is
got
not
it.
proper. That is the problem. Okay, but yeah, we need to add this into activity guide once this is successful. Please. Okay, match label.
Sure, Ramesh.
Yeah, and then we can use the pod selector here. And this is my match labels for the pod. And this is my role. Okay, fine. So we need to change some details here, guys. So basically details are like, let me remove this egress from this one. We need to write some data here. Let me change it here. Okay, I'll make it short NP2 so that I don't have to type it again more. Okay, then pod selector was my namespace is equal to app.
App NS. Oh, sorry, app. Yes.
Right. policy type is this one, name selector is match label, and here I was actually trying to do something else, right? But let me just try it from the one namespace that let's allow the traffic coming from the namespace called or server called as
app NS. Oh, you are allowing the traffic from where?
So we can do it from the web, right? Web.
Yes, yes, yeah. So the traffic is coming from web to app.
Yes, web to app, it will come, but not from the DB to app. Are you getting it? We have 3 namespaces, right? We are just using, once we select this web NS, get the traffic from this app to, web to app, that means automatically other things will get denied only. And now I will not, I will not just use this one because this is not required. Pod selector, let me just comment out this, guys.
Ramesh, one question. So the namespace selector you have said allow from WebNS. So is that going to restrict from other namespaces?
Yes, it will restrict from the other namespaces. It will only allow from this namespace.
Ramesh, the namespace will be default or it will be app NS because you created a separate namespace.
I want to do it on the default only. Let's check it. I want to do this on the default.
It should throw error now, right? Yeah. I mean, while executing the command.
It should be app. It should be app NS, right? Namespace name.
No, namespace name is perfect, right?
No, default. If you want to change the custom.
Metadata, yeah.
No,
or
but
let's
I don't
see
want
how it behaves. Yeah, let's see how it behaves.
Yeah, let's see how it works.
Yeah.
I don't want to check that, right? So it should fail. It will not fail, guys. Let me try out this. You apply F network 1 YAML. It got created, right? So it got created inside the default namespace, but whether it is applicable, it is getting applied on the other namespaces or not. That is what I wanted to check, so that whatever earlier understanding is clear. Okay, now cool. So what we have done the let me go to the diagram now. First of all, what we have done, we have allowed the traffic from, this is allowed, right? As per the this is allowed, this traffic is allowed, this is blocked, and we have deployed in the namespace called as a default. Now let's see that. So to check this one, I need to go to this particular pod, and from this pod I need to try to ping this pod, whether it is pinging or
Ramesh,
yeah.
Before you do that, can you show us where is the default namespace here in the diagram?
Here.
Now it's there.
Okay.
Yeah, it is true actually. It is there true only, right? This is C kubectl get namespace. This is another namespace. Sumanta, right?
The default
C.
one. Okay.
This
Okay.
is the default one.
Yeah.
That is what as okay. Now let me go to the name pod. First of all, let's kubectl get pods. I need to use get all -o wide. I think this will give me the proper information. So I have these pods and I need to check the label also. Show labels.
I think we shouldn't be able to ping from web to app also.
Okay, let's see whether we are able to. So let me go inside the, first of all, where is my pod? I created somewhere, right? But it is not showing the pods now. It is showing from the env pod, this one, but it is not showing the pod from the.
Select the namespace. I think these are default.
It's a default, right? That's why.
Thank
Either
you.
you will set context or -n.
Get pods. I was thinking that whether you people are awake or not. Okay. Web. Wide -hyphen show labels. And then this app, and this is my beep. Yeah, please mute, guys. Okay, cool. So this is the information that we have. Now what should I do? I should log in into the DB1, this pod. Yes, let's log in. Hyphen execute hyphen IT And let me go to this pod db1 space dash. Yeah, why it is failing?
Namespace.
Namespace, thank you. And what is the namespace? db1, right? But still it is failing. Namespace is correct, but something I have given wrong. What is that?
ISH instead of dash.
Is it DB or DB1? DB.
Namespace is DB, right? And
Names DB is not DB1, and the pod.
name is DB. Yes, correct. Now from this one, I want to ping the app one, right? And it should not ping. That is the thing. So apt update. apt install IP utils dash ping -y. Cool, but now where is IP?
My guess is it will work.
From DB. So from we are
Yeah, you
inside
have
the,
applied to default. You want to apply a default namespace, not to app namespace, right? When you created network policy.
So let's see now. Yeah, it is pinging. So it is applied. It is working fine, right? So that means it is
Yeah,
the
why it is because you have applied the network policy to default namespace. That's why it's working.
okay. So let me change it now.
Appness.
This is where should I apply?
Appness,
Now
right?
put app NS.
App NS, right? So it is only app NS, right? Or app only app NS, right?
App NS.
And also WebNS, right? We're not doing both.
No, this is only app, right? Namespace is app, not app NS.
Okay, yeah.
So pod label is app and namespace level is app NS, right?
Yeah, and see here now kubectl get NS. You can see here this is my app, DB, and web. These are the three namespaces.
Okay, got it. So I confused with the and
But what is the label of what is the label of app?
Can you show hyphen labels?
Yeah, the labels are app NS. Server is equal to app NS. Server is equal to DB
Yeah.
NS.
So
yeah. So then I think we need to apply those labels, right, Ramesh?
No, here we don't have to write because I am just deploying the policy here. You see here now. This is my network policy.
Okay, got it. Makes sense, yeah.
This is namespace is app, right? I'm deploying it here, and the pod selector namespace I have taken it. And from which namespace it should not ping? From the name selector called as the WebNS. It should ping only, and from others it should not. From the DB namespace it should ping. It should not ping, right? So let me deploy this now. kubectl get namespace network policy. So let me delete this kubectl delete net policy called as np2. Now let me apply it again. kubectl apply -f network 1.yaml. Oh, I'm so sorry. kubectl typo. Okay, so it is deployed now, and where it is deployed? It is deployed kubectl get namespace net policy from the namespace called as app, right? You can see here. And now let's describe this one. kubectl describe. So we can see what are the rules there, what it means, right? Describe. You can see that it is allowing the ingress to port any allowed from namespace called as a whose label is server is equal to MNS. So this is working now. This got deployed properly. Now let's see. Control R kubectl execute.
So it will get the traffic from web, but not from DB.
Yeah. So now what I'm doing, I'm going to DB1 pod, right? I'm inside it, and now let's try ping 13. Yeah, it is blocked. So from you see here, we have already got the IP addresses, right? So this is the IP, this is my pod DB1, and the IP address of my application is this one, 32.0.5. It is not pinging, so it is blocked. But it should work from which namespace?
Web.
Which pod?
Web.
Web 1, right? And this is my namespace called as web. So let me pick up this IP address again. Ping. Okay. apt update, and I need to create my own apt install IP utils dash ping -y. Yes, and now it should work. Ping, and this should be ping, right? Because we have allowed from the web 1 to the app 1. So this is ping. Yes, it is ping. Is that clear now?
Yes, Ramesh, very good exercise. Thank you.
Thank you.
So Ramesh,
So
when to use default or when to use the proper namespace? What is the difference? I mean, it works both way, right?
No, it doesn't work both way. If you want to take action on this in this namespace, you have to create a network policy for this one.
So, but the default was also working, right? When it was on
No,
default,
it was failed. It was failed.
Yeah.
It was
we were not able to ping from web, is it?
We were able to ping from all.
Oh, okay.
No, actually he was confused. Like I think pod was able to ping, which shouldn't happen when you have given default. Got
True.
it.
No. Let me summarize it. Let me summarize it quickly, guys. Let me summarize in one liner. If you want to, let's say, if you want to deploy any network policy on the pods or in the namespace, on the pods of the specific namespace, please deploy the network policy in that namespace only. If you want to take the action on this particular pods and you are deploying the network policy here, it is not going to work. Okay, so please keep this in mind. I hope that we have done very good exercise, guys, on the network policy, and you might have understood clearly now what is network policy. I request all of you to please do the activity depending on the sports and everything. Now this is very much understandable component, right? If you want to specifically block the specific ports or something like that. Okay, can you see this? Yeah, this is port 5000 or so from the label whose pod, so you can see this ingress rule right here. Okay, so ingress rule is that from pod selector whose label is role is equal to monitor, okay, will have access to the port number 5000. But where it will have access on the port number 5000, where the pod selector is equal to whose label is API server. Okay, so it will have access to the 5000, but not to any other ports. Is that clear? Yeah. Now you can get that CIDR. Okay, I think you will have a lot of examples, but I will suggest you guys don't try for the big examples. Create simple examples and deploy it. You will understand it better. Okay, try with the port also. Try with the ICMP traffic. Try with the UDP traffic, like 53 port or something like that. You'll get a better understanding of that.
Ramesh, where is this port?
So Ramesh, if we
yeah, go one by one, please. Yeah, now you can ask the questions, guys, if you have any.
Yeah, means where is this port located? That the 5000 port, is it in the means where I am going to block or
Container port? It is container.
okay.
So Ramesh, this we don't need to select a pod selector. If we one pod specific one pod, then we don't need to put pod selector, right? We can just give the pod name.
Correct, absolutely correct. No, specifically I have see now one network policy which I created right now. If you see here, This was very simple network policy. I have not used anything. Let me just show you. I have not used any specific pod. We have just used the namespace selector. So any pod from this namespace selector will be able to access the pods whose label is ns is equal to app. Then if you want to further go down and put some more rules, then you can put here pod selector whose match label is this one or that one. Further, if you want to put specifically, if you want to put for the port number, you can say that, oh, this port number in the ingress, you have to put this port number, 2 port numbers only, it should be accessible. You can write the port number. Or if you see that, no, particularly from the CIDR, right, from this particular subnet, if you want to access, you can add that block there. That's called as IP blocks.
And we can get these all details, what like a switch or parameters we need to define. We can go, kubectl explain network policy, which will give you all the, specs and ingress and port selectors, what kind of different things we can add into this YAML file.
Correct. It will give you that information for sure, Vivek. It will definitely give you, as well as you can get it from the Kubernetes document as well. So if you try to do that one, kubectl explain and network policy. Am I correct? Is the spelling correct?
Spelling mistake.
Yeah, you can see that what are the different fields are there. API version, kind is there, metadata is there, and you should be more specific about the specs, right? So then you can use command kubectl explain, okay, network policy dot, am I correct? Spec.
Typo again.
Okay, sorry. Yeah, network policy, and now see here. So now you will get all the subsets of the network dot specification. So in that one, you can use egress, ingress, pod selector, policy type. Now inside that also, if you want to find out something called as about the ingress, then what you can do, dot ingress. Then you will get all the properties of this ingress. What are the fields are there, from and ports. So this way you can go ahead. In case you don't know about this from, just type it here. It will give all the properties of the from, right? IP block, namespace selector, and pod select. That way you can go, guys, right? All right. I hope that this network policy topic is completed properly, right? And everybody has understood it. If you have any questions, guys, please ask. I can take a question for 5 minutes, and then I want to move to the another interesting concept called as the security context. I wanted to finish it actually today. It is not getting finished. Okay. All right. Thank you, guys. So let's go ahead and discuss about the security context. What is security context? A security context defines a privilege and access control settings for a pod or a container. Okay, so let's say that you have created a pod and you want that pod or that user which is there inside the pod a specific privileges. Okay, for that purpose you need to define a security context. Now it is coming to the pod level, guys, container level, right? It is not something related to namespace or not cluster. It is completely related to container and pod. So permission to access an object like a file. So what is the meaning of this one, guys? If you logged in into the system by using a normal user in Linux or in Windows, okay, so you will not have all rights. You need to use a sudo command, or you will not be able to change the IP address of the system, or you will not be able to install certain specific commands in your system, right? Because you are not a privileged user. So similarly in a pod also, if that pod is not having a privileged user or privileged access, then that pod will not be able to create anything in the kernel namespace. It will not be able to access the block devices. It may not create some files and folders, right? So if you want to allow certain specific privileges inside the container, you have to use the security context. Is the concept clear? Then we'll go for the example.
Yes.
I'll show. Yeah, right. So interesting thing is that users are there in the pod, right? And you want to make them some privileged, or you want to remove some privileges from them. If you want to do that kind of stuff, you have to use the security context. Okay. Running as privileged or unprivileged user gives a process some privileges, but not all the privileges of the root user. So that is called as a privileged user. So these are some definitions of the security context, guys. You can see mostly it is you see the same definition which we have seen earlier as well. Like this is the definition for your pod, and nothing changes up to this point. Everything is same. It is a simple pod definition, right? It is creating a container of Alpine. It is just writing it to just sleep for this many seconds. That's it. But it has added in the properties of the containers. What it has been added as a property in the container security context, and what it says that run as a user 405. Okay, so this is basically not a privileged user, right? It is just a normal unprivileged user. So this user will not be able to perform any activities. It will perform only simple activities which has been assigned. All right. But then there is a second definition you can see here. It is the same to same. There is no changes in the definition of pod. But you see here, this is showing security context. Run as not root. So is equal to true. That means it is a non-privileged user. So you might ask me this question that what is the difference between this and this one? Okay, and we'll see that one. And third one is it shows that privileged is equal to true. Okay, so we'll discuss about this one. Okay, so 405 is a UID, user ID of this is a Linux user ID. Okay, and all right. So what is the meaning of run as non-root? Let me just complete this. I will come back to you. Just nothing but run as non-root user is nothing but while creating the container, it might use a root, but when you start logging inside that one, it may use a non-root. It will say that please. So it will allow you to install something like that while creating a container, but once you enter into that one, it will be non-root user.
Which user it will be? Non-root means which user?
Any other user specifically, any other user.
We have not created any users in container, right?
Right, you can create, but you can do that. You can run the container as a non-root user. You can create the user. If I want to create a container with the name called as Vivek, I can do that one, and it can run the name called as Vivek as well. Okay, so it has certain steps are there, and you need to. No, it will not pick up arbitrarily. So whatever there is in the 405, I think there will not be any user called as a. There will not be name against this 405. We'll see that, guys. Let me just try to show you. And this is another context. You can see that if you want to add certain capabilities inside the pod, this is for adding the capabilities. You want to change the system time. You want to drop the capabilities, that is you don't want to allow that user to do the change on, that is do not change the owner, right? This kind of permissions you can capabilities you can either
but Ramesh, in the second right, but in the second thing, if you don't add root, I mean by default it will be used as logged in as a execute the command as a root, right? By default, if you don't have any security context. But when you are going to add security context and capabilities that drop chon, but that means the user root will also not have a permission to has a chon.
Right. So because the root which you use in the container, it also doesn't have all the permissions to change the parameter inside the OS one, right? So let's say that let's say that you want to change the kernel parameters of your host operating system. So the container root will not be able to do that, right? So you need to give the additional permission to the container root so that it can have the capabilities. So this is what it means. You can add the capabilities or you can drop the capabilities, right? All right. So let me show you this now. A couple of examples, guys, from this one, so that we can quickly close this one.
So one question. So what does it changes inside the container? Is it changing the permission of the specific command or something like, or at what level the control is done?
You are asking about the
OS wise container inside the container, like OS.
No, see, basically what happens actually when we create any, please mute for some time. When we create any pod, okay, and inside that container is there, it uses some space at the local host. So let's say this is my master or worker node, and on worker node I have deployed the pod. So it used the certain parameters called as a namespace parameter, such as IPC or such as its PIDs or such as its mount parameters from the local operating system. So let's say this is the state for that container. This is the space in which all that parameters are defined on the OS level for this particular pod. So whenever you give the privileges to this particular pod as the root user to add the capabilities or drop the capabilities or something like that, it will be able to perform the task inside only that namespace. It cannot go outside here. This will not be able to change.
Thank you. I got it. So basically, from the OS level, you can enter into the namespace and change it if you require, unless
yeah, right. So let me show you the couple of examples so that you can understand it, guys, right? Let me quickly complete this one. Okay, so I have activity guide. Let me go to the activity guide side, guys, so that we can do it quickly. So defining the security context with a default user. So I'm creating the first container. This is my Alpine container. Okay, let me create it. Okay, and now you can see that kubectl get pods. It got deployed in where? It got deployed in the default namespace, right? Okay, cool. Now check the ID of this container. How I can check the ID of the container, guys, without going inside the container? Kubectl execute and the name of the pod and use the ID command, and this will help you to understand by which user ID this particular container or pod is running. You can see it is using a root user ID, right? You can see a lot of information is there. Okay, and you can also check this one more command, how many file systems it can see. Sorry, I need to use this command, ls /tab. You can see it has a certain amount of it can go to the core, FD, full, but not all. We will be creating this user, we will be changing the capabilities of this one, and we'll see that it will have the access to more number of files inside the /dev, because /dev is a very big directory. Inside that, a lot of files are there, but only few files has been seen by this user called as a root user of that container. Okay, now once this is done, let's define the security context with the specific user. So I have this context file vim security.context, and look at this, guys. It says that this is Alpine user context. This is the name of the pod which we are creating, and we are asking to run this particular pod as 405. So this will run the pod container inside the pod with this user ID, guys. Let me show you that. So kubectl apply -f security context.yaml. It is created now. Kubectl get pods. Now you can see that Alpine user context pod has been started. Now kubectl execute. Now see here, and ID. It is showing 405. And as somebody says that you can you change this one? You can change it. Let me make it here. Let me try out 6005.
Do you want to give only the user IDs, or we can give the name also, like root or any name if we already created user IDs?
But we are not sure whether that user is there, right?
Okay.
So let me apply this one. So it is configured, and now you can see kubectl get pods, and this context one pod is started because I have just changed this UID, and now you can check the ID number. It will be whatever the ID I have just given, context one. It is 6005. Okay, so that user ID should be present. You have to create the user with this user ID, then it will work that way.
How do you know how many users are there and what are the...
In Linux, if you're asking about the Linux, you can create 2 raised to 32 minus 1, this many user IDs in one Linux machine. Okay. Okay, now we have created the security context for the user with the user ID called as a 405. That's done now. Yes, correct. It is a user ID of the user. Perfect. Okay, check the user context. So we have checked it, guys. Now till this point we have just done it. Defining a security context with non-root users. So let me try out this particular file, guys, with non-root user. Open this file, and this is the same file. It is showing run as non-root user, right? True. Rest of the things are same, guys. Let me deploy this. kubectl apply -f security context as a non-root user. It is done. Now you can see here kubectl get pods and see that this is non-root user has been, oh, but it is showing some error. It might not have privileges to create it, right? So let's see that what is the problem. So you can see whenever we create it and it is in the pending state, or it is giving some error, right? This error is coming up when we create a non-root because it doesn't have privileges to create it. So what should we do now? So you see here, this is the error coming up, right? So we need to provide the security context such as privileged is equal to true. So let me use this one. Because it doesn't have the permission to create the root, that's why it is failing. Container has run as non-root and image will run as root, so that is the problem. So whoever has created this image has a, so let me describe this kubectl describe pod. You might be thinking why it is failed, right? So it is because it is failed because error is showing container has run as non-root and image will run as a root, and that is a problem. Whoever has created this Alpine user has a root user ID. It is not, this image is not created with the normal user ID or non-root ID, and that is why it is failing. Either we have to give the privilege to this user to create a run as a root, or else it will not work. That is the only option, or else we have to create the image with the normal user ID. So this is going to fail. So that is what happened when we create any container with non-user ID, non-root user ID. So we have used the user called as a non. So this is showing this way, run as non-root. So whatever the user ID is there, that will pick it up.
So in this case, who is a user? You or?
No, user is this one. User, there is a, see, while creating a container, there is a kubeadm user is doing this job, right? But while creating a container, it uses the user which is defined inside the image.
Okay.
Right. So if it is not defined, it considered to be a root user because we create an image with root user ID or something like that, right? And if you are specifying that user space Vivek or user space, let's say Abhiram, that means it will use that user while creating a container, right? So Docker file, while creating a Docker file, you need to specify that user. Otherwise, you privilege it. And if you want to privilege that, you have to give the this particular context. So let me now.
Ramesh,
Thanks, Ramesh.
is it failed because in the image it is declared as a root, and in our case we are declaring as a non-root. That's why it's failing.
Absolutely correct. Okay, so let's create the user with the security context called as the privileged is equal to true and see whether it is working or not. So let me go here. You see that it shows the privileged is equal to true. Security context is equal to privileged is equal to true. Rest of the things are same. So let me save it here. And this is the property of container, guys. Security context is the property of containers. Please note down that. Save. kubectl apply -f security context privilege is equal to YAML, right? Let me see. And now it has created a container, but it has a privileged root, right? You can see here. This has got created privileged pod. And you can see here kubectl describe pod called as a privileged pod, and you should be able to see that created a container main, it is working fine, and it is used root user only, even though it doesn't show here, but it has used the root user because it is using a privileged user. All right, it is showing privileged pod, so it is working fine, guys, now, right? Now, so now since it is a privileged user, and now see how many pods it can see, how many files inside the /dev folder it can see. Now see here, kubectl get pods. This is my privileged pod. Let me access this one. kubectl execute privileged pod, and let me see ID. So it is a root ID. Now can I see ls/dev? And you should be able to see more files here, guys, because it has a root privileges. Can you see? So it is picking a lot more device files than from the pod if you are giving the security context called as privileged is equal to true, right? So you can see more files, guys. This is the difference between the normal user and privileged one, guys. I hope that you got this down. So this is what I wanted to show you, and it is there. You can also try to change the time on default container pod with the help of this command. So we are trying to change the time for this particular pod. So you can see, guys, here kubectl get pods. So I have this pod called as a defaults. Okay, and it is a normal root which has been assigned, right? You can see here kubectl execute this pod, and if you try to see ID, it will show you the root, but it is a normal root. It is not a privileged root inside the container. And if you try to set up the time inside the container with this particular user ID, it will not allow you to do that one, and that is what this specific command will do. kubectl execute -it pod with defaults, and it will set the date, and it should give you this particular error that date can't set data operation not permitted, because it doesn't have that permission. It is a normal user. So now you can do it here, and you should get this particular error, date can't set date operations not permitted. But will this command work with the privileged pod? Yes, it will work, and that is what we are going to see now. So add capability that we can see, or let me set up this particular same command with the kubectl execute with the privileged one. Let me try out if it works here. Privileged pod. Yes, it has set. Okay, because it has a privileged access, that's why it is able to change the time inside the pod. Okay. All right.
Ramesh,
I hope
the live scenario, like because this thing we need to take a consideration while designing the container, right?
No,
So
I can change the ulimit parameter from this place. Let's say that you want to change the ulimit parameter, ulimit hyphen, let's say A. Let me try out. And this is my hyphen n option is 1024. Let me try to change with the privileged ulimit hyphen n 2048, and let me see if it works. No, it is not allowing me to do that. And there might be some specific way I need to specify this command.
No, space between minus minus and ulimit, I think.
No, it is not picking up. There is this syntax is there. I'm trying to follow this syntax. Let me check this if I can use in the double quote. Which ulimit? Oh, there is no ulimit in this particular specific Ubuntu, but it should have, right? Chmod 777 etc password. It is done. But which password file it has changed? It has changed the file inside the container. Let me go inside the container now. ls-l etc password. So it has allowed to change the.
So did you use the capability? That's why.
I have not used the capability. I have used the privileged user, right? ls-ll. Yeah, I don't have to use IT, right, for to see this one. ls-l.
So the command has to be dash space first.
No, I think it should work actually. It should work. Yeah, see, yeah, thank you very much. So it is working fine. See here, it has changed the permissions of the files inside the container. Look at this. Ideally, it should be your 777 000 because password file has a, or I can change in that matter. I can change the permission of shadow file also.
Maybe Ramesh, if you can also show the capabilities that restrict the root user itself.
Yeah. Yes,
To change
that
the
is
permission.
there, but I hope that you understood that you can use the privilege user to change whatever you want to change. Now see here, I changed the shadow file.
But like that's what my question is. Like, if you are designing a container, we should we should give a permission or some sort of a privilege so that somebody can change the password with using this command, right?
Yes, correct. So basically, you should not allow to change by this command because this is very dangerous. This is very dangerous. That's what I'm doing here. So we should not give the root privileges to the specific container, right? So how you can do the capabilities? So how we can limit by using the capabilities, right? So let me, guys, this is just last exercise. Let me quickly close this. I need your 5 minutes of time. Okay. So you can see here. Now this will help you to, it is allowing you to change the kernel change parameters with the help of add capability. So let me just quickly execute this. kubectl apply -f. So it has created a new pod, kubectl get pods. You see here, kernel change pod, right? It has been created. Now let's see that whether you are able to add some fire that command to change the whatever the parameter we have specified at the system time. So create the pod that will allow you yes, we have created. Now let's see that whether this allows you to change the, because it is not a privilege, right? It is just add the capabilities and it is allowing you to change it, right? But you will not be allowed to change the permissions of the file, right? That is, this command will not be allowed because this capability is not given to you. All right, this should be failed actually. This should be failed.
No, it's a, you have not mentioned the root user or non-root. I mean, you need to put the capabilities on top of that. Which user or which user ID?
Yes, that is also true, but let me check out. ETC shadow, has it
But in
changed?
this case, then it should, so even if you provide a privilege also, but this code 7.7 will not work on that kernel level, right?
Yeah, it will not. It will not. This is not changing the kernel level. So it is changing inside the pod. That's, I think that this particular user ID has the rights to change the permissions of the ETC shadow file. And that's what
Okay,
has come.
inside you have 777. That's why it is changing.
Right. Because this is a normal user and it has a privileges to do that one inside the pod. And that's why it is doing it. But it
No,
is
he's
not
saying
having.
he's saying because the files are already having that 777 privilege. That's the reason why it is.
No, it will have a 00 permission only. It will not have a 77. What I'm saying, when we create a container, right, that container has a root privilege ID. This root user ID, not privileged. This might have the rights to change permissions of this particular files. So irrespective, you have whether you have given the added the capabilities or whether you have added the privileged user, this user has rights to install the packages. This user has the rights.
Ramesh, if you
right?
don't have a privileged user mentioned in your security context YAML file, you have only capabilities edit. So that means it will run as a root. When you run the command, execute command, it will run as a root user, right? And the capability will come into picture. Let's do one thing. You restrict capability as mkdir so that root user itself cannot create any directory.
No, this is basically
no. If you don't mention any privileged user, it will be act as a root, right, by default. Correct? And
right, but
just only add capabilities and capabilities as mkdir. That means you are maybe you are restricting a root itself not to create even directory also as well, just for testing purpose.
So you want to say drop. You have
Correct,
to use a
drop. Yes, the drop. So you basically also restrict user root also to drop mkdir.
So we can change only chmod now. This is the only option is available. Let me make it changes here in the same file. So this is the root capabilities, right? So let me open this VI, and rather than this one, I will use drop here.
Correct, that's fine.
Okay, and what is that drop you want to? You don't want this user should be changed.
Or mkdir or chon, whatever the command we need to. Yeah.
chmod will do that, right? Okay, and let me change the kernel name, pod name, because we want to create a new pod to test this one. Let me save it here. kubectl apply -f security, guys. Just a couple of minutes more, not more than that. Okay, the time.yaml. Yeah.
There was one. You forgot one.
What is the mistake I have done?
It should be drop. You will drop in capital.
Drop and change mode. It's in a caps. Is that works?
Okay. Yes, small. Drop should be small. Thank you. Yes, it is created now. Let me try to change the permissions, right? Because we have dropped it. And what is the pod we have created? This pod, kubectl get pods, create container error. Yeah, this is that pod which we, why it is clear. Pattern. Dash ch1. This is correct. Right? Let me use this ch1. I think this should have worked.
Simple put mkdir, right? Let restrict mkdir so that node user can create a directory.
But is it taking capital? That is the only, because these are some specific keywords. Let me make it 2. Let me save it here. And kubectl apply security.yaml. It has created, but is it really created? Git pods. Not getting created. It is showing error. So what is the error?
And describe to see the logs where the error is.
I think chmod and it should be added privileges, right? Okay, not kubectl get describe pod successful. Yeah, this is not right. This is not allowed. Caps lock for mkdir. I think from where we can get that list of the commands. Let me try out small one. Maybe it will have a different. So I will use chown because it is known. So this will not allow you to
Do one
change
thing,
the
Ramesh. Do one thing. Create one file, and then once the file is there, and then we will create a chown capability to make sure that the change owner, chown permission is not there.
Yes, correct. That will do this. Yeah, understood. So let me use this pod 4 now. kubectl apply -f, and this is my file. kubectl get pods. This should be created. 4th one, yes, it is created now. So let me create a file, right? So how I create a file inside the container without logging into the container? kubectl execute. This is my container name -- touch /home/1.txt. Will it create? Because it has a privileges, right? And
Yes.
we'll check it with it. Yes, and we'll check it whether it is created or not. --ls-home/1.txt. So it has been created. Can you see?
Yes. Now apply the capability.
Yes. Now we can use the chown, right? chown. Let me use command bin home.txt. Not operated. Permission not permitted. Yeah, this is working. Because it is not allowed. We have dropped the capabilities.
Good. Thank you.
Yeah. But I can change the permission if I
Even
need.
the same root can it change? Change ownership with the root.
A root?
Yes, which is already existing.
Okay, that we'll try to see. Yeah, it is. Yeah, it is allowed because it is not change. It is not a change ownership, right? It is not a change ownership. Are you getting it? So even if I try here IT like this one, it is not working. What I can do here, I can use one command called as group add IT. No, this privilege is also not. This privilege is also not there to the user. Normal user, root user. Okay. So what is the understanding of this exercise? Why we did this exercise? Then can you please mute for some time? What is the understanding of this user? This exercise is that normal user doesn't have, normal root user doesn't have all the privileges such as like group add or maybe changing the time or some other parameters, right? If you want to add the capabilities to that user, you can use command add capabilities, right? Like this one, which you have done, capabilities add or drop, it will work. Understood? So, and if you are
better
using
to so where we can get these keywords like capital CH1 and all these things?
I think we need to search inside the security context, then capabilities. Inside that, I think we'll get it. So pod, containers, security context, and capabilities, like that. The way I have shown you a little bit earlier, kubectl, explain, right? So that is your pod dot spec dot containers dot security context, yeah, and these are the options you get. Run as non-root, okay, all these options are there, and inside that we have to check what are the let's say that capabilities. We have add and drop. Now you have to use add. I think this way you will get some, but it is not showing you here as a all the strings which you need to use. You have to use a bash or some other commands. Okay.
Ramesh, when we did the add command, we can able to also perform some more operations apart from that, I think.
Yes, yeah. If you use add instead of drop, if you use add capability, you can give the more, you can assign more operations to it. But if you don't want to do, you can use a drop here. Correct?
No, means we only gives only one operation, but we can also did the ch mode which you means perform. Means
Yes. Because ch mode was that rights are there to that particular user, root user, to change the permissions. But when you drop it, it is removing it. If I use a ch mode command, it will not change the permissions of the files as well.
okay, means that root has some extra privileges because though the capabilities are not declared.
Right. Yes, correct. But it is not like a privileged root user.
Oh, okay. Got it.
All right.
Ramesh, where we need to maybe last question, I'm not sure, but where use cases of this security context, like where we have to use in Kubernetes. I know this is container level access or privilege or capabilities. We need to restrict somebody to access containers, right? I understand that we can restrict the users or what they can do in the container level, but still I'm not understanding exactly where we will apply. This is security related, right? I think that's why we need to get more detail in deep dive at the container level. We need to revoke the access.
So basically, guys, if you want to, you have to create the user with the normal root privilege, not without privileged one. Create a container with normal one. It will have a limited privileges. But if at all, sometime your application requires more number of processes or more number of open files, and you might have forgotten to let's say that adding in the configuration file. Okay, so during that period, I think you can use this one to you can use this specific one for adding the capabilities or dropping the capabilities. Since it is a pod, it can recreate if it is in the deployment phase. Do not use for the static pod. It will create a problem. So if at all you have to use it for the specific purpose like changing this system time or kernel parameters in the runtime, or we don't want to configure it as the config map or some other way, that time you can just you want to change the single parameter. I think this will help you to do that.
So Ramesh, when you say kernel parameter, this is the parameter of that pod only, right?
Yes, that pod only.
Right. Okay.
So
Thank you.
it is not an ideal way. See, basically in the config maps, see, in the config map, we can provide the values, right? Key and values. But there is no other way by which we can assign the commands to the user, which is a user of the container, right? So this is the only way we can add the commands or drop the commands from the pod. So you can take care of it while creating the container or after creating the container, after creating the pod as well.
Ramesh, that one question, like when we create a pod is based on a container, right? But it will be in a read write only, right? Because the container, it will be created from the image with, and once we create a container, it's on read write only. RW.
No, this is not getting implemented on the image one. This is getting implemented at the container level. Once the image is extracted and it creates a container, that time only we can use it.
But ultimately the container, it's created from the image only, right?
Yes. It is created from the image only. Correct. What is your question? I think I'm not.
No, I'm just trying to understand. No, I'm just trying to understand a scenario where actually we are going to implement, because ultimately we are working or making changes on the container only, right?
Correct. Huh? No.
So,
see,
but
basically,
if you are restricting, suppose like if you are restricting the config file, everything means we don't want anything to be exposed to the outside world. Then how we are going to use these privileges?
Okay, let me put it in the simple language. Just give me 2 minutes, guys. While creating a Docker file, do you have any options to provide the additional capabilities inside the image? No, right? So, and if you want to give the certain rights to your container, that please, or you don't want to give the certain rights to your user, okay, how we can remove or add that capabilities? So we can write a security concept for that.
I think you can execute namespace enter command from the operating system using the container process ID, and it can become root user and do whatever you want to do inside the container.
If you are a root user ID from the operating system kernel host level, host worker node level, you can do anything with that kernel, but anything with that kernel or with the container. The problem is that, do we want to assign the privileges to the user which is there inside the container, which is driving the container? That is what this.
Normally, we don't give any access to the user, to the containers.
Yeah, and if you have to drop it.
Yeah, this is the way. It is good example.
Right. Okay.
Thank you.
All right, guys, I think that's for the day now. I think we have completed the 2 topics today. Only 1 topic is still left out, Piyush. I don't know how we'll manage it tomorrow. Okay, and that is, which is the topic? Which one is left out?
Config map, yeah.
Right. So we'll take it the next session. Yes, Piyush. I think I have taken a lot of time, guys.
Hey, Ramesh, one question. Last question, maybe. This security context is applied at the pod level, right? Means container itself.
Yes,
but we are not creating a pod manually, right? As a best practice, we also use to create a pod by deployment. So in that case, it will be on the deployment level, or so that all the pods automatically get the same security context.
Yes, correct. Yes, correct. That is correct. Actually, you are saying it correctly. Sorry.
And one more question.
Yeah, one second.
I'm sorry. One more question.
Yes, let me take the questions from the chat box also. What is the question, Abhiram? I have not answered.
One question is like, if I want to have the multiple capabilities listed in YAML file, you have given the chown and then drop capabilities or add multiple capability? How do I do that?
I think this is a kind of key value parameter. It is coming as an array. I think I can define
It's a list. Yeah, it's a list.
We can use that one. I can use list here. This should work. This should work actually.
Okay.
Thank you for asking that question. Any other question that I have not answered, guys, please?
So Ramesh, we were trying with this example of user 406. So my understanding is that it was a pre-existing user, right? 406?
406 is not the pre-existing user.
Will
Ideally,
it be created runtime when we deploy this?
it will be creating a runtime user.
Okay. And there's a Linux user.
This will be Linux user, right?
No, but Ramesh, it is just creating a virtual capabilities. It is not creating a user 405. You have to log into the pod or container as a root and then create a user with 405 ID. Then it will get the privilege set context, right? It's not creating a user ID with 405. It is just getting a privilege. Giving a capabilities.
No, it is creating user ID. You see here, run as a user.
You are saying that 405 user will automatically created by this?
Yes, it will create. It will create.
So
that's why it is showing me the output of ID command, right? Okay. If you see here, guys, kubectl get pods, and now see here somewhere. This was the pod. Which was the command? What was that? 1 second. Let me try out. What is the pod? Kernel change? No, not kernel change. There was another pod. What was the name of it? Not privileged.
Just create another pod with 405 capabilities or whatever, and see whether user is created.
It's Alpine user context.
Before that, we have to check if that user already exists or no, and then we can go ahead and.
No, it won't be. See, basically, we are creating the new pod itself. While creating the new pod, inside that container parameter, we are saying that run as this user. So let me log in this into this container and show it to you. I think it is a bash or SH. It will be SH, right? Yes. And now you see here ID. It is showing 405.
Oh, that's good, right? So we don't need to create a users. If you have a multiple users requirement, that this command is good.
Yeah, and I need to check. Let me just show you etc password file. If it allows me
It would be a pain if it does not. You have to get the users created and get them assigned.
Yeah, it is creating. See here.
Yeah, makes sense.
Yeah. And it is login as that user as well. It is creating with that user.
That's good. Good to know.
Yeah. Okay. It's beautiful, guys. The way it requires a lot of time to work on this one. Yes, Abhiram, security context is to pod level only, right? Yes. It is a container level. Instead of 405, I can use, yes, you can use any UID.
But in that case, Ramesh, that 405, so how do I know there are other user ID? Because I can list all the user ID or?
No, it is. So basically, as per the Linux, if you know the Linux, 0 to 999 user IDs are, or in 0 to 999 user IDs are specifically reserved for the system user IDs, and all other IDs you can use for the any purpose. So if you are not sure, use the user IDs 2000, 3000, 5000, no problem.
So Ramesh, if we don't have user ID 405, it creates a user ID with 405 ID, right? If we already have a user ID created by the root users, let's say 401, 2, 3, 4, 5 IDs, 5 users are created with the IDs.
It will assign that.
It will not create, but it will assign the. It will provide the privilege. That's it.
Right. Yes.
Can ID root give user ID or ID user name can give the user ID of the username? I mean ID
Sorry?
command.
ID command. Okay, so guys, I created one more user. I don't remember that whether I created it or not. It is showing 6005 right here. So I just want to see whether it has created 6005 or not.
Go to shadow file.
Shadow, I think it will not allow me to check because it is a permission is not denied. It is denied. So it has logged in with the user ID 6005. I need to log out from this one and again log in with the root user ID and then it will work. Okay. It has, I got this one, see, 6005. It is not like that it is not created. It is created, but it is, this user 6005 doesn't have the privileges to see the information of the etc password file completely. Anyway, guys, this is a really big thing. It is not showing me that by using this user ID, I have to log in with the user called as root. Let me see if I can. No, this is not coming. Sudo is not installed in this one, so it will not work. So there is no use of it. So guest user, if the question is asked by somebody that if you have already created a user called as a guest and if you use that user ID, so it will be assigned the existing user ID. It will not create a new one.
Okay.
In that case, will it show this in the log that it is already created a user and you're
No,
just
no.
It could be tricky because that user might have many accesses and we might not want to give all sort of access. So in that case, probably it would be good to cross check whether this user exists or not.
Yes.
And if
So
it does, then what's the
right way to create a user is in the Docker file.
right? Okay. Yeah. Thank you.
All right. Okay. Any other question that I have missed, guys? Please, you can ask me.
Ramesh, I have out of the topic question. Sorry, that's why I said last I will ask.
Yeah, Sundar. You tell me.
So my customer environment is having multiple clusters. So we have UAT environment and prod environment. So the UAT environment, we have two different regions, Central India and Europe region. So both are intended for same workloads, but as per GDPR compliance, we are maintaining two different region, two different clusters.
Okay.
Now customer is complaining that they created Central India cluster, they created a Redis service, and they would like to communicate from EU, like Europe region cluster to the Central India region, the Redis service. So that Redis service is deployed with default cluster IP. Like service means it will not use the custom network which we have given, right? We are using Azure CNI model.
Okay.
Custom networking. Yeah. So how do I fix that issue? Like, do I need to ask customer?
Do one thing in this case. You have two clusters, right?
Yes.
So it is one is your let's say prod. I'm just taking the example as a prod, and another one is your test. Correct. Right? And there is one service inside this one that you want to this customer want to access from this place, right? Like this one.
Correct.
So what you can do, you just create one service endpoint here as a load balancer for that service, only that service, and map it to some DNS or something called as public, or you can use the public IP address of the load balancer in case it is internal users, or map it to the some domain name, subdomain name, and give that domain name to them to access it from this server. Did you understand what I said?
No, I didn't. I did not understand.
Okay.
Sorry, I'm taking your time.
No, what I'm saying that you have one application running here inside this one.
Before that, I have VNet peering already. The communication between these two clusters. So the clusters are sitting on my custom defined virtual network range, right? Both are having VNet to VNet peering.
So that means you are able to, no, but anyhow, that doesn't make any thing related to the customer, because customer you will not get the access of the cluster to it, right? You want to give the access of the application to the customer. What is
I think he is talking that there are two services, Ramesh, and those two services can be through load balancer and ingress controller. And ingress controller has a path-based routing. One is for prod service, other for test service.
No, he's saying different. There are two clusters, he's saying.
Two different clusters, like both are for UAT clusters, but as per GDPR compliance, we are maintaining the GDPR compliance. Like Europe region should be a different cluster, and the India region will be a different cluster.
So you are saying that API server, there are two API servers you are using.
Exactly. Two API servers, correct.
So only one way is there to access this one, I feel, which is a good one, is that this is your application, and this application is whatever the service is there inside this one which is running. I feel that you should expose that to the external load balancer and give the access to the customer of that particular link. Then only it will work.
Okay, so is it possible if I can like a pod structure, like pods we are creating inside that containers, right? So this Redis service itself not using that node port type. Like I'm not sure. Like node, like we have to use node port, right? Node port
Yes,
type.
you can use node port, or you can use a load balancer with node port.
Yeah, they are using load balancer from the target where it is trying to communicate the source. Source is left side. Now you are defining prod.
Okay, so from this one they want to communicate to the Radish service which is there inside here, right?
Correct.
Okay. So that's fine, no problem. I think they should expose this one to the load balancer, outside load balancer, and you give the access of the load endpoints of the load balancer to this one, and they will be able to maintain it. But make sure that you properly created targets behind the load balancer. I hope that this is a I hope that this is a proper native Kubernetes installation.
Right. This is the direct AKS. This is not hardware configuration.
Right. Then it will clear a load balancer for you. It will work.
Yeah, I think Sundar, you need to create two separate load balancer, and whatever the prod is talking to the test environment, then you need to give that test environment load balancer external IP, need to configure to this prod. By the way, it can talk to each other. That's the solution.
Okay, but why don't we use internal IPs only, since we are having already
since your cluster IP address are different, right? They are the different clusters, right? And you are not using a public IP addresses, and so that cluster IP addresses, in case you want to do that, if you want to have the cluster to cluster IP, that cluster IP to cluster IP communication, then you have to add some you have to create one more routing, but then it will be a really there will be some issue then if you are creating routing. So I think this is a very easy way to do that rather than creating an internal routing.
Yes.
See, this is not your Azure VNet. VNet to VNet is there, but this is not this inside the Kubernetes. It has own networking, right? How it will communicate with your own networking, which is inside the Kubernetes with CNI configuration, right? And the VNet IPs and those network is different.
Right. The problem is that they are having two altogether different clusters. That is the problem. So these IP addresses which are there inside this one, it is completely private here, and these IP addresses are completely private here.
It should work. It should work only with load balancer.
Yes, so I have the same scenario. I faced this one. So the best thing is to go ahead with the load balancer external IP address, and you need to configure that to the production, the way of configuration. The prod need to be configured with this one. So it's an easy way. Instead of going with an internal cluster configuration, you need to go with an external configuration. But there is a time delay. There is a time delay of, because it's coming from whatever the region, from India region to another region. So there is a time delay in between, but the best process is this only, instead of going with of internal communication.
If you don't mind, could you please share me that commands if you have in the chat window so that I can try?
Load balancer. No, we have to check that. It is just expose command which is there, right? You have to use the expose command. Expose command. kubectl expose. kubectl expose deployment. Whatever the deployment you have used, let's say it is, if it is a test deployment, and or let's say in my case it is app or pod, expose pod 1. I have app 1 right here, going with app 1. Yes, app 1, and I can write here type is equal to load balancer, and port is equal to Reddish was on which port?
6739.
Yeah, 6379, and okay, and that's it. This is the only thing that you need to do.
I think we need to give the, instead of load balancer, we need to give external IP. Oh, the load balancer is external IP. Yes, right.
External IP will, yeah, it is expose pod, right? Is it a pod or app 1 is my deployment? Is it pod? Okay, anyway, guys, no problem. So you have to use this way, right? If you use this way, it will work.
Can you please copy that command and paste in the chat window so that I can try to give a try in my lab?
Sure, do that. You check out the command in case something is wrong there. It might be that yours will be deployment and not pod.
Yeah, deployment. It is not a pod.
kubectl
SVC. Okay.
Yeah, understood. Create deployment called as let's say test 1 -- image is equal to nginx kubectl expose deployment / test 1 with type called as load balancer, right? And port is equal to, let's say in my case it is 80. Now it is created. Now you can see that kubectl get svc, and here you can see that now it is pending showing because it is my not a cluster oriented native deployment, right? So you can, right? So this is the command.
Give it to me. Yeah.
Okay.
Perfect.
All right. I think I guys now little bit late today. It is already midnight here. You can say in the India. I don't know you from where you are right now, guys. So let's stop for the day now. I hope that you enjoyed today's session. You got something out of this, right?
Yes.
Yes. And guys, one more question that he asked me. Chudi has asked me the question: how do I get the Kubernetes HA? Are you there still, Chudi? Can you hear me?
Yes, I hear you.
Yeah, thank you. How are you?
I'm doing fine, thank you.
Thank you. I don't have right now this prepared documentation for the cluster installation, HA cluster installation. I am in the preparation mode because I need to create a lecture for all of you for the discussion of the high availability cluster and something else also, right? So I'm creating that one. Once I prepare, I will definitely share with you. Don't worry about it.
Ramesh, whatever we are doing, all the cluster configuration is not as an HA, because it does have the 2 worker nodes and we are maintaining horizontal.
No.
It doesn't come like as an HA.
No. See, basically, if I want multiple master nodes, that means actual HA will come into picture. Because right now, if I have if something goes wrong with my master node, I don't have any backup.
Okay then. So okay, I got it.
You got it right.
But Ramesh, that HA will be in a primary and secondary replica mode, right? Or will be active.
It should be in the active mode. Basically, when we have a discussion about the cluster, now that time I will explain. But it is not dependent on the hardware. Okay, Kubernetes master servers HA is not dependent on the hardware. It depends on the services which you are using. So that we'll discuss in detail if you don't mind in the cluster lecture.
Oh, okay.
Yes, Gavin, you will get all the commands. I request. What is the name of this guy? Piyush or another person was there, right? So please give these commands to them, all of them, guys. Garvit and Piyush, please.
Yes, Ramesh, we are uploading all the commands on the portal already.
Yeah, thank you, guys. All right, guys. Sorry for the late, Piyush and Garvit. Okay, I know that you got late too.
Yes, also, I'm listening these sessions with you actually, so I'm learning also with you. So that's not a problem.
Okay, but the problem is that we are not on the track, right? I still today I missed one session, but the one topic is not covered. Okay.
Oh no problem. We will cover this. This is also worthy for everyone, I think.
All right, guys. I hope that you are happy with this session, right? Thank you very much.
Super.
You please.
You are awesome.
Thank you, Ramesh.
Yeah, thank you very much, guys. Take care and have a nice time. Bye. See you tomorrow.
Yeah. Good night.
Good night.